Above our solar system stretches an ocean of invisible light, waves of energy, time, and memory that never sleep. Below it lies a cosmic underworld, hidden structures of dark matter and gravitational rivers that cradle the sun like roots beneath a tree. Tonight, we journey through both realms to discover the hidden architecture of the solar system and what truly surrounds us. Because what lies above and below our cosmic home will shock you. Like and subscribe, and let us drift beyond the ordinary together. Let's begin. High above the ecliptic plane, our solar system floats in a cosmic sea of plasma and interstellar dust. This region, known as the heliosphere's outer shell, glows faintly in ultraviolet light, a bubble carved by the solar wind that shields us from the galaxy's radiation. We tend to picture the solar system as a flat disk of planets orbiting a calm sun. But in truth, it drifts through a vast ocean, one that is invisible, turbulent, and alive. The sun is not static, it breathes. With every heartbeat of fusion, it exhales a stream of charged particles that spread outward in all directions, forming a great sphere of influence around us. That breath of light and magnetism becomes our first and last defense against the raw energy of the Milky Way. This ocean has no waves in the way we know them, but its currents are immense. The solar wind flows outward at over 400 kilometers per second, pushing against the interstellar medium, the thin gas and dust that fills the space between stars. Where the two meet, a boundary forms, the heliopause, the true edge of our solar system. Beyond it, the sun's influence fades. Inside it, we are sheltered. If you could rise above the solar system and look down from millions of kilometers away, you wouldn't see a tidy circle of planets. You would see a shimmering bubble moving through darkness, its surface rippling with energy. The outer layers glow faintly in ultraviolet light, shaped by the magnetic fields of both the sun and the galaxy beyond. It's not a perfect sphere, but a distorted comet-like shell, stretched by the motion of our system as it plows through the Milky Way at nearly 230 kilometers per second. Above the sun, the solar wind thins into wisps of plasma, folding into invisible magnetic arcs that guide cosmic rays and trap charged dust. Below, the same patterns twist downward, bending beneath the ecliptic like deep ocean currents beneath a stormy sea. Together, they form a kind of cosmic weather system, ever-changing, unpredictable, yet vital to life on Earth. We live entirely within this hidden ocean, protected by it, shaped by it, and yet unaware of its constant motion. Every radio signal, every particle of sunlight, every breath of air we take has passed through it. When the solar wind weakens, more galactic radiation seeps in, subtly changing Earth's atmosphere and perhaps even influencing the climate. It is humbling to realize that everything we know, every star we see, and every story we've told about the heavens exists inside this invisible cocoon. It is the ocean we were born into, and the one we will eventually drift beyond. Voyager 1 has already crossed its edge, into the interstellar current beyond the sun's reach. But even from there, it can still feel faint ripples from home, a whisper of solar wind traveling through the dark. What lies above and below the solar system is not empty space, but the silent motion of a living boundary, a shimmering ocean of light, plasma, and dust that defines the edges of where the sun ends and the galaxy begins. Far beyond Neptune, the sun's influence begins to fade. The solar wind slows, folds, and collides with the galactic medium, forming a shimmering boundary called the heliopause, the true edge of the sun's domain. It is here that the solar system exhales its final breath. The solar wind, an endless stream of charged particles born in the sun's corona, races outward for billions of kilometers, carrying magnetic fields and fragments of the sun's energy. But eventually, even light's emissaries meet resistance. Beyond the orbit of Neptune, where the sun's warmth is only a whisper and darkness reigns, the wind encounters the faint pressure of interstellar gas and dust. This is where two great forces meet. The expanding breath of our star, and the eternal tide of the galaxy. The result is not a hard wall, but a transition, a slow, glowing frontier where the solar wind is bent and folded back on itself, like waves curling before the shore. The space here is neither solar nor galactic, but something in between, a liminal region, electric and restless. At this distance, more than 120 times farther from the Sun than Earth, the light that sustains us is reduced to a faint glimmer, no brighter than the full moon. Temperatures hover near absolute zero. The Sun's voice, carried by radio waves, takes more than 18 hours to reach this far. It is the outermost whisper of the solar system, the boundary where our star's breath becomes still. Voyager 1 crossed this threshold in 2012. Voyager 2 followed in 2018. Their instruments recorded the moment the solar wind dropped away and the density of cosmic rays suddenly spiked. Beyond that invisible veil lies the interstellar medium, the raw material of the galaxy itself. Hydrogen, dust, and ancient particles from supernovae drift there, unshaped by any single star. To cross the heliopause is to leave home, to enter a realm where the Milky Way becomes the only horizon. And yet, the boundary is alive. The heliopause ripples and shifts like the surface of water, responding to solar storms and the cycles of the sun. When our star erupts, shockwaves travel outward for years, colliding with that outer wall and causing it to expand and contract. The edge of the sun's breath is not fixed. It moves, flexing with the pulse of our star's life. Standing there, if such a thing were possible, you would see nothing but blackness. Yet all around you, invisible energy would be colliding, twisting, exchanging charge and motion. The sun's last influence, faint but enduring, would shimmer in electromagnetic echoes. Beyond that, the galaxy stretches infinite and silent. The heliopause is not merely the end of the sun's reach. It is a mirror, showing us how fragile even a star's dominion can be. Our entire solar system, every planet and comet and speck of dust, exists within a single breath of stellar wind, one that fades into the endless sea of the Milky Way. Here, at the edge of the sun's breath, the familiar ends. Beyond it lies the unknown, the true interstellar dark, where our star's light is only a memory, and the galaxy itself begins to whisper. Encasing the entire solar system is a vast, ghostly halo of comets, the Oort Cloud. 1 trillion frozen worlds orbit in silence, each one a time capsule from the birth of the sun, drifting tens of trillions of kilometers from home. It is the solar system's outermost veil, an invisible sphere so large it may extend halfway to the nearest star. The Oort Cloud is not a disk like the planets or a ring like Saturn's. It is a vast cocoon of ice and dust, surrounding everything we know. Here, gravity grows uncertain. The sun's pull is so weak that passing stars, or even the tides of the Milky Way itself, can tug these icy relics free, sending them plunging inward after billions of years of stillness. Each of these frozen wanderers is a message from another age. Many formed in the dawn of the solar system, when the planets were young and chaotic. They were cast outward by Jupiter's immense gravity, flung into deep space where time moves differently. In that endless cold, they became monuments of memory, untouched, unchanged, waiting in the dark. No light from the sun reaches them directly. Temperatures hover just above absolute zero, where even nitrogen and methane become rock hard. Their orbits stretch so far that one journey around the sun can take millions of years. When one is disturbed by a rogue star passing near, or the subtle tides of the galactic plane, it begins a long, slow fall back toward the light. As it approaches, sunlight wakes the ice. It begins to glow, to weep vapor and dust, and what was once invisible becomes a comet, its tail burning across our skies. These fleeting comets are our only glimpses of the Oort Cloud, the edges of a structure too immense and faint to ever be seen directly. Each one that appears is a messenger from the frontier, carrying clues about what the solar system was before Earth was born. Within their frozen hearts lie traces of ancient water, carbon, and organic molecules the seeds of everything that would one day live. And yet, for every comet we see, there are billions more we never will. They drift through a realm so distant that sunlight takes months to reach them, a quiet halo of potential and memory encasing us all. The Oort Cloud is both the boundary and the beginning, the place where the solar system ends and the galaxy begins to take hold. If you could look upon it from afar, you would not see a bright sphere, but a faint, shimmering mist surrounding a tiny point of light. Our entire solar system, planets, moons, asteroids, everything is just a speck at its center. The halo is vast enough to swallow entire civilizations 1,000 times over, yet delicate enough to vanish from sight completely. The Oort Cloud is not just a region, it's a silence that surrounds us, a frozen archive of creation. It is the ghostly echo of the solar system's birth, watching over us from the dark. And somewhere out there, in that frozen infinity, the next great comet is already falling home. Though space appears empty, the solar system swims through an invisible current. The Local Interstellar Cloud, a slow-moving river of charged hydrogen that flows around our heliosphere like wind against a ship's bow. We often imagine the planets as motionless jewels orbiting a still sun, but in truth, the entire solar system is moving, sailing through the galaxy at nearly 230 kilometers per second. The sun, the planets, and everything that orbits them drift together through this cosmic river, wrapped inside the protective bubble of the heliosphere. Like a ship gliding through unseen waters, our solar system parts the interstellar gas before it and leaves faint ripples behind. This river is incredibly diffuse, so thin that each cubic centimeter of space contains only a handful of hydrogen atoms, and yet, when stretched across trillions of kilometers, its effects become profound. It presses gently against the heliosphere, shaping it like wind shaping the sail of a ship. It defines the edge of the sun's influence, sculpting the boundaries of our cosmic home. We call it the Local Interstellar Cloud, but it is neither calm nor uniform. It is part of a larger structure, a tangle of filaments and cavities carved long ago by supernovae. Our solar system just happens to drift through one of its thinner folds, a region of slightly warmer, denser gas surrounded by vast voids. Someday, millions of years from now, we'll drift out of it entirely into another pocket of space with different density and pressure. When that happens, the heliosphere will change shape. Its magnetic boundaries will flex and shift. Cosmic radiation levels may rise or fall. Even the cosmic weather that brushes against Earth's magnetic field could subtly alter. To the eye, this river is invisible. It has no color, no glow, only the faintest whisper detectable by ultraviolet telescopes. But to a spacecraft, its presence is undeniable. When Voyager 1 crossed the heliopause, its sensors recorded a sudden change in particle density, a sign that it had left the calm of the solar wind and entered the flow of the galactic tide. It was the first human-made object to touch the current beyond the sun's reach. Within this vast flow, our solar system is a traveler. The sun's magnetic field acts like a bow wave, deflecting the interstellar hydrogen that crashes against it. Behind us trails a long wake, an invisible tail of solar wind stretching for hundreds of billions of kilometers. If we could see the Local Interstellar Cloud from above, the image would be humbling. A swirling river of gas and plasma, and within it, our entire solar system, a tiny glowing bubble sailing through the tide, its faint light barely visible against the cosmic sea. This river beneath the planets reminds us that space is never truly still. Every star, every world, every particle of dust is adrift in motion, caught in currents that began long before our sun was born. We are passengers, not pioneers, carried by invisible tides through a galaxy still breathing from the echoes of its own creation. Above and below our plane, gravitational tides from the Milky Way slowly tug at comets and planets alike. Every few million years, this cosmic tide stirs the Oort Cloud, sending icy messengers hurtling inward toward the sun. We often think of gravity as something that binds, the force that keeps our feet on the ground, the planets in orbit, the stars held together. But on the grandest scales, gravity also pulls apart. The Milky Way's immense mass creates a tidal field, a slow, invisible stretching of space itself that ripples across the solar system like the rise and fall of an ocean. Our sun and planets orbit the galactic center once every 230 million years, bobbing gently up and down through the thin disk of the Milky Way. Each time we cross that plane, we pass through denser regions of gas, dust, and dark matter. And with every crossing, the galaxy's gravity tugs ever so slightly on the outermost edges of the solar system, the fragile realm of the Oort Cloud, where comets sleep in frozen exile. It is here that the galactic tide performs its quiet work. The pull is too faint to disturb the planets, but across trillions of kilometers, it adds up. Comets that have slumbered since the birth of the sun begin to drift. Millions of years later, they arrive as sudden visitors, bright comets blazing across Earth's skies, carrying within them the oldest material in existence. Each of these icy messengers is a consequence of motion on a galactic scale. A comet's fall is not random, it is a whisper of the Milky Way's gravity, carried across light years of emptiness. The tides that move our oceans are echoes of the same law that moves the stars, binding every scale of existence into one continuous rhythm. But the galactic tide is not gentle. As the solar system drifts through the galaxy, it sometimes passes near other stars. Their gravity, too, tugs at the Oort Cloud, stirring it into new patterns. Some comets are captured by other systems, others are flung into interstellar space forever. And occasionally, one is thrown inward with enough precision to find its way to Earth, its icy heart vaporizing into a glowing tail, a brief spark of beauty born from cosmic motion. It's a reminder that the solar system does not exist in isolation. We are part of a vast, living galaxy, where everything moves in slow harmony. The same gravitational forces that shape galaxies also sculpt the paths of comets. The same tides that pull stars into spirals ripple through the frozen edges of our own home. Above and below the solar system, these unseen forces rise and fall like the breathing of the Milky Way itself. Every 30 million years or so, they reach their peak, stirring the Oort Cloud anew. In their wake, the sky brightens with comets, brief visitors born from the deep tides of the galaxy. We are adrift in that rhythm, carried along by the same tide that moves worlds and stars alike. It is not chaos. It is motion, slow, patient, eternal. The galaxy breathes, and with each breath, the solar system sways. Astronomers now suspect that an unseen structure, perhaps a concentration of dark matter, threads through our region of space. Though invisible, its gravity may guide the long-term motion of every planet we know. We live surrounded by something we cannot see. Dark matter, an invisible substance that neither emits nor absorbs light, makes up most of the universe's mass. Yet it does not behave like normal matter. It passes through stars, planets, and even our bodies without resistance, shaping the cosmos through gravity alone. It is the silent architect of galaxies, the unseen scaffolding that binds the stars together. Though we cannot detect it directly, its influence is everywhere. The way galaxies spin, the way clusters of stars hold together, even the very pattern of the cosmic web, all point to a hidden mass we can't perceive. Astronomers believe that the Milky Way sits inside a vast halo of dark matter, extending hundreds of thousands of light years in every direction. Our sun, our planets, and every comet orbit not just the visible disk of stars but this invisible halo as well. Within that halo, faint variations, subtle concentrations of dark matter may thread through our region of space like invisible rivers. As the solar system drifts through them, these unseen filaments could exert minute gravitational forces, tugging ever so gently on planets, asteroids, and distant clouds of ice. Over millions of years, these nudges might alter orbits, shift trajectories, or even help shape the slow dance of the Oort Cloud itself. It's an eerie thought that everything we know, the paths of worlds, the rhythms of seasons, the boundaries of the solar system, is being steered ever so slightly, by a form of matter we cannot touch or measure directly. Dark matter does not shine, does not scatter, does not burn. And yet, without it, galaxies would tear themselves apart. Stars would drift into the void. The cosmic web would collapse. Scientists have tried to detect dark matter particles for decades, building detectors in deep underground chambers, launching experiments aboard satellites, and scanning the sky for hints of annihilation radiation. So far, they've found nothing. It is as if the universe's most powerful force prefers to remain unseen, shaping everything while revealing nothing. Some theories suggest that dark matter might gather more densely in certain galactic regions, forming streams that the solar system periodically passes through as it orbits the Milky Way. If true, these invisible tides might subtly influence how comets are dislodged, how orbits precess, or even how the Sun itself moves within the galactic disk. We may not feel these effects on human timescales, but over millions of years, they may be written into the very geometry of the solar system. Dark matter is, in many ways, the mirror of the known. It is everything our senses cannot perceive, yet everything our existence depends on. It reminds us that the universe is not only stranger than we imagine, it is stranger than we can imagine. So, when we look into the night sky and see nothing but the bright points of the visible cosmos, we are, in truth, staring into a dark reflection. An unseen ocean beneath the stars, vast and silent, holding us all in its invisible embrace. As the solar system orbits the Milky Way, it passes through zones of higher radiation, dense gas, and cosmic dust. These galactic seasons may subtly influence everything, from comet impacts to Earth's climate. Our Sun is not fixed in space. It sails through the spiral arms of the Milky Way, orbiting the galactic center once every 230 million years. Along that vast journey, the solar system drifts through regions of changing density, some calm and clear, others thick with gas, plasma, and debris from ancient supernovae. These are the galaxy's breaths, slow and powerful, rising and falling across cosmic time. When the solar system moves through a dense region of interstellar gas, the heliosphere, the Sun's protective bubble, shrinks. Galactic radiation seeps closer. More high-energy cosmic rays penetrate the solar system, brushing past Earth's atmosphere and subtly altering its chemistry. Some researchers even wonder whether these cosmic variations could influence our planet's long-term climate, seeding clouds or changing the balance of heat trapped in the air. As we travel deeper into the galaxy's arms, the skies themselves shift. More nearby stars, more supernovae, more dust clouds glowing faintly in infrared light. Between these arms, we drift through the quieter interstellar voids, thin, clear regions where radiation from the galaxy's core streams freely across space. The solar system's environment is not static, it's an ever-changing current of energy and matter. Every 30 to 40 million years, the solar system passes through one of the Milky Way's spiral arms. In those epochs, the night sky would look subtly different, denser with stars, dimly lit by nebulae. The frequency of cometary disturbances might rise as the galactic tides pull at the Oort Cloud, and Earth might endure more frequent impacts from icy wanderers. Some scientists have even suggested a faint correlation between these galactic crossings and cycles of extinction and renewal on Earth. The idea that our planet's fate could be linked to the solar system's slow drift through the Milky Way sounds poetic, even mystical, but it's rooted in physics. The galaxy is alive with energy. Cosmic rays from distant explosions, clouds of molecular gas, waves of magnetism from ancient stars. All of it forms a vast breathing ecosystem that we pass through with every beat of cosmic time. Right now, we are in a relatively calm region between spiral arms, known as the local bubble, a cavity carved long ago by dying stars. Here, the radiation is low, the gas is thin, and life on Earth thrives beneath the sun's steady protection. But this serenity is temporary. In a few million years, we'll drift again into another region, another breath of the galaxy, where the conditions will change once more. Perhaps that's why life itself must adapt. Because even as the Earth spins and the planets turn, we are all part of a far greater cycle, the slow inhalation and exhalation of the Milky Way. The galaxy breathes, and we move within that breath, fragile travelers riding the unseen rhythm of creation and destruction through darkness, dust, and light. Our entire solar system bobs gently above and below the galactic plane, rising and falling through the Milky Way like a leaf drifting on waves of gravity. Each full oscillation takes roughly 60 million years. Though we think of our orbit around the Milky Way as a smooth, flat path, the truth is far more graceful and far more complex. The solar system doesn't simply circle the galactic core, it undulates through space, swaying up and down through the thin disk of the Milky Way. Like a boat moving across rolling seas, we rise toward the galaxy's northern side for tens of millions of years, then sink slowly back through the crowded midplane into the southern galactic hemisphere. This motion is caused by gravity itself. The mass of the Milky Way, stars, gas, dark matter, creates a kind of galactic tide that constantly pulls us toward the plane where most of its material lies. But because our system has momentum, it overshoots that equilibrium, rising and falling in a rhythmic wave-like motion. Each full oscillation, from one side of the galaxy's disk to the other and back again, takes around 60 million years. To us, these shifts are imperceptible. The motion is so slow that in a human lifetime, the solar system moves only a fraction of a light year up or down. But across deep time, this vertical motion becomes a kind of heartbeat, a cosmic rhythm in which our system breathes in and out of the galaxy's densest layer. When we cross through the galactic plane, we pass through regions rich with gas, dust, and dark matter. The gravitational tides here grow stronger, tugging at the Oort Cloud and stirring its icy fragments. Some astronomers believe that this vertical motion may occasionally trigger waves of comets to fall inward, lighting up the inner solar system, and perhaps, at rare intervals, bringing catastrophic impacts to Earth. Others suggest that the increased density of the galactic midplane could affect the heliosphere itself, compressing it and allowing more cosmic radiation to reach our planet. Rising above the galactic plane, the view, if we could see it, would be breathtaking. Below us, the Milky Way's disk would spread out like a luminous river, its spiral arms glowing faintly with starlight. Vast dark lanes of dust would wind between them, like shadows crossing a celestial ocean. Beyond that, the halo would shimmer with ancient stars and globular clusters, the fossils of an older galaxy that once was. Then, slowly, we would begin to fall again. The galaxy's gravity would draw us downward through its bright disk, through regions of molecular clouds and young star clusters, until we pass through the midplane once more, only to rise again on the other side. A perpetual cycle of ascent and descent, an endless galactic tide. This gentle bobbing may seem insignificant, but it's part of the Milky Way's larger dance, a rhythm shared by countless stars around us. Every sun, every planet, every world with its own stories, all swaying together in a slow cosmic waltz. We are passengers in that motion, carried through the galaxy not in a straight line, but in a long, graceful wave. And somewhere, within that rise and fall, life on Earth continues, small, fragile, and yet perfectly in step with the pulse of the Milky Way. The Sun is not stationary. It travels at 828,000 kilometers per hour around the galactic center. Every atom in your body is in constant motion, spiraling through the galaxy's arms in a dance that began before humanity existed. Even when you stand perfectly still, you are moving. The Earth spins beneath your feet, racing eastward at over 1,000 kilometers per hour. The planet orbits the Sun at nearly 30 kilometers per second, and the Sun itself, carrying with it every planet, moon, and fragment of dust, circles the Milky Way's core in a vast 230 million-year orbit. This is the Great Passage, our endless voyage through the galaxy's luminous rivers of stars. It's humbling to realize that everything you've ever known, every mountain, every memory, every breath, rides on a star that's crossing the galaxy at incredible speed. Yet we feel none of it. There's no wind, no sound, no vibration. Space is too empty to resist us, too vast to care. The solar system moves silently, carving its own path through the dark. As we travel, we drift through the spiral arms of the Milky Way, regions thick with gas, dust, and newborn stars. Each arm is a slow wave of density, where gravity gathers the ingredients for creation. The sun passes through these arms roughly every 100 million years, a rhythm that has continued for billions. Each crossing changes our cosmic environment, subtly altering the flow of radiation and the frequency of nearby supernovae. The galaxy's center lies some 26,000 light-years away, a gravitational heart dominated by a supermassive black hole called Sagittarius A star. The Sun orbits this distant core as part of a vast stellar stream, moving with thousands of other stars like sparks caught in the swirl of a cosmic whirlpool. Together, they form one glowing thread in the Milky Way's spiral tapestry, each star following its own curve through space-time. From our vantage on Earth, we see only the illusion of stillness. The stars appear fixed, their patterns constant. But across millions of years, the constellations twist and fade. The sky is fluid, the heavens are alive. Orion will one day dissolve, the Big Dipper will stretch beyond recognition. The map of the night will change, even as we drift onward through the galactic sea. To imagine this journey is to feel small and infinite. The atoms in your body were forged in ancient stars that once orbited this same galactic center. They, too, took part in this long passage, drifting through time until they became part of you. You are not separate from the galaxy, you are a continuation of it, a spark carried forward by the same momentum that drives the sun itself. In another 230 million years, the solar system will complete a single orbit, a galactic year. By then, Earth's continents will have shifted, its oceans reshaped, perhaps its life transformed. And still, the sun will be moving, steady, luminous, unending, through the arms of the Milky Way. The Great Passage is not something we choose. It is something we belong to. Every heartbeat, every sunrise, every orbit of our planet is part of this grand motion, a silent voyage through the stars, carrying all of human history along with it. Between planets, magnetic fields twist and collide, forming invisible sheets of energy known as heliospheric current sheets, cosmic windsocks that ripple with the sun's rotation. Imagine a vast spiraling membrane of charged particles, stretching billions of kilometers from the sun, wrapping around every planet like a ghostly veil. This is the heliospheric current sheet, a colossal structure that marks the boundary between magnetic regions of opposite polarity in the solar wind. It is the largest continuous structure in the solar system, yet it is entirely invisible. It begins deep within the sun, where tangled magnetic fields are born in the roiling plasma of its outer layers. As the sun spins, once every 27 days, these magnetic fields twist and stretch, imprinting their shape onto the solar wind. The result is a gently rippling spiral that extends far beyond Pluto, undulating through space like a slow-motion wave frozen in time. To visualize it, imagine the sun as a great rotating lantern, with its magnetic field lines streaming outward in all directions. As it turns, these fields twist into a pattern resembling a ballerina's skirt, an elegant spiral of charged plasma known as the Parker spiral. The current sheet follows this shape, separating regions of positive and negative magnetic charge across the solar system. Every planet passes through this layer as it orbits. When Earth crosses it, our planet's magnetic field senses the shift, causing subtle changes in the flow of charged particles that reach us. These crossings can affect the solar wind's intensity, influence space weather, and even alter the behavior of auroras shimmering at Earth's poles. Though invisible to the eye, this sheet is constantly moving and breathing with the sun's magnetic cycle. Every 11 years, when the sun's magnetic poles flip, the current sheet warps dramatically, becoming wavier, thicker, and more turbulent. During solar maximum, it can extend like a storm-tossed sea of magnetism, sending surges of energy across the solar system. During solar minimum, it flattens out, calm and thin, like a quiet tide. Spacecraft such as Ulysses and Voyager have passed through this unseen layer, feeling its subtle push. Instruments recorded shifts in charged particles, proving that even in the dark between worlds, the sun's magnetism is alive, stretching its influence far beyond sight. The heliospheric current sheet is one of the universe's most delicate architectures, an electromagnetic fabric woven by a star's rotation, reaching across billions of kilometers to touch every planet it has ever given light to. It is the layer we never see, but always live within, a living reminder that space is not empty. It hums with motion, charge, and balance. We drift inside its folds, bathed in its unseen rhythm, carried by the sun's pulse as it beats through the solar system's magnetic heart. Beyond the Kuiper belt lies a mysterious population of objects called detached bodies. Worlds like Sedna that orbit so far from the sun that they seem to belong to no system at all. The known solar system, as we picture it, ends with Neptune and the frozen debris of the Kuiper belt, a region filled with dwarf planets, comets, and icy fragments left over from creation. But beyond that familiar frontier lies something stranger, a realm of lonely orbits that defy logic. These are the detached worlds, celestial wanderers whose paths stretch thousands of times farther than Earth's, looping through the darkness in silence. The first of these was discovered in 2003, a reddish, icy world named Sedna. Its orbit is so vast that it takes over 11,000 years to complete a single trip around the Sun. At its farthest point, it travels nearly 1,000 astronomical units away, more than 30 times farther than Neptune. Out there, the Sun is little more than a bright star, and the warmth of its light fades into cosmic night. What makes Sedna and its kin so mysterious is their detachment. Their orbits don't interact with Neptune or any known planet. They seem suspended between two realms, too close to belong to the Oort Cloud, yet too far to be shaped by the known solar system. Something else must have placed them there. Some scientists believe these objects were thrown outward billions of years ago by a passing star, an ancient visitor that briefly disturbed the outer planets before drifting away. Others suspect something even more profound, the gravitational influence of an unseen world, a massive planet lurking far beyond Pluto, Planet 9. If it exists, its gravity could have sculpted these detached orbits into their strange, aligned patterns, tracing its hidden presence like ripples around a stone dropped into dark water. The detached bodies are cosmic fossils. Their icy surfaces preserve the chemistry of the early solar system, untouched for billions of years. They are made of water, methane, and ammonia, frozen relics from a time when the sun was young and the planets were still forming. Yet what they tell us most is that our map of the solar system is still incomplete. We once thought Pluto marked the end. Then we found the Kuiper belt, and beyond that, this hidden population, half in shadow, half in myth. Each discovery pushes the edge farther outward, showing us that the solar system doesn't end with light, but fades gradually into uncertainty. In the spaces beyond Neptune, gravity becomes a whisper. The sun's warmth is a distant echo, and time itself stretches beyond comprehension. Here, Sedna and others like it glide through orbits shaped by forces we barely understand, tracing silent arcs through the deep. The detached worlds remind us that the solar system has no true edge, only layers of mystery, stacked one upon another, each revealing that there is always more beyond what we can see. Every planet, moon, and asteroid is connected by threads of gravity, an invisible web that shapes tides, orbits, and the stability of entire worlds. Even the smallest rock plays its part in this cosmic fabric. Gravity is the quiet architect of the cosmos. It has no sound, no color, no pulse that we can sense, yet it binds everything together in a single continuous motion. Every particle of matter, no matter how small, tugs on every other. The sun pulls on the planets pull back on the sun, moons tug at their parent worlds. Even an asteroid, drifting unseen between Mars and Jupiter, leaves its faint signature on the dance. If we could see these connections, the solar system would look like a web of glowing filaments, stretching and bending in slow, rhythmic motion. Each planet would sit at the center of its own field, its gravity extending outward, overlapping with others to create a delicate balance. This invisible structure determines where worlds can orbit safely and where chaos reigns. Earth's tides are one expression of this web, a daily whisper of the moon's pull, felt in the rise and fall of our oceans. But tides aren't limited to water. They stretch the crust of our planet, flex the shapes of moons, and even heat the interiors of distant worlds. On Io, Jupiter's powerful gravity kneads the moon's insides like dough, fueling volcanic eruptions that light up the darkness. On Europa and Enceladus, it stirs hidden oceans beneath ice, keeping them warm enough to harbour the chemistry of life. The gravitational web also governs the paths of asteroids and comets. Some regions, like the asteroid belt, exist in fragile harmony, kept in place by the balanced pull of Jupiter and the Sun. Others are chaotic zones, where overlapping resonances send objects tumbling inward or flinging them out of the solar system entirely. The orbits of the planets themselves are stabilized by a complex interplay of gravitational exchanges, a dance that has endured for billions of years. But the web is not static. It breathes and evolves. When large objects move or collide, the ripples spread across space, changing orbits far away. Even the migration of the giant planets in the early solar system, when Jupiter and Saturn shifted positions, reshaped the web forever, scattering countless smaller bodies into the Kuiper belt and Oort Cloud. Gravity extends beyond our sun's reach. The solar system itself is caught in the Milky Way's gravitational field, circling its center in a slow, majestic orbit. That same force keeps entire galaxies bound together in clusters, and clusters bound within the vast cosmic web that spans the universe. From the smallest pebble to the largest galaxy, every motion is connected, each one tugging, each one responding. We often imagine the universe as empty space dotted with isolated islands of matter. But in truth, it's a single fabric, a living, breathing network of invisible threads. When one world moves, another feels it. When a moon rises, a tide responds. When a comet falls, a planet trembles ever so slightly in return. We are all part of that web, suspended in motion, held by forces older than time itself. Gravity doesn't simply pull, it connects. It's the language through which the universe holds everything together, and through which everything listens back. Below the tranquil orbits we see today lies a history of violence. Ancient impacts between protoplanets carved the early solar system into its current form, scattering debris that still rains upon us as meteorites. The calm, clockwork precision of the solar system, the steady arcs of planets, the elegance of orbits, is an illusion born of time. In its youth, our cosmic neighborhood was anything but peaceful. The planets we know today are the survivors of chaos, born from dust, forged in fire, and sculpted by collisions that reshaped everything. 4.5 billion years ago, the solar system was a disk of gas and rock fragments whirling around a young, blazing sun. In that crowded arena, billions of planetesimals, small, growing worlds, crashed and merged, each impact releasing energy greater than any weapon humanity could ever build. Out of that chaos, the planets slowly coalesced, their molten surfaces glowing with heat from constant bombardment. The Earth itself was once just one of these wandering protoplanets. Its creation was not gentle. A cataclysmic collision with a Mars-sized body, known as Theia, tore away part of its crust and threw molten rock into orbit. That debris would eventually cool and clump together to form our moon, a silent witness to the violence that gave us our tides, our stability, and our nights. Mars bears the scars of similar catastrophes. Vast basins like Hellas and Utopia are ancient impact sites, so large they reshaped the planet's climate and history. Mercury's enormous iron core may be the remnant of a world stripped of its outer layers by a titanic collision. Even Uranus's strange sideways tilt likely comes from a long-ago impact, so powerful it knocked the planet onto its side, changing its seasons forever. And though the age of planetary collisions has mostly ended, its echoes remain. The asteroid belt is a graveyard of worlds that never formed, a shattered region where Jupiter's gravity prevented full planetary birth. Every meteor that streaks across our skies tonight is a fragment of that ancient chaos, a messenger from the time when worlds were still being born. Some of those fragments carry secrets. Locked within meteorites are clues to the solar system's earliest chemistry, tiny crystals that predate Earth itself, and grains older than the sun, formed in the dying breaths of other stars. Each one is a relic of cosmic creation, a piece of that violent dawn when dust became stone and stone became world. Even now, collisions continue in slow, subtle forms. Microscopic dust impacts spacecraft and planetary rings. Comets break apart as they near the sun, shedding fragments that may one day rain upon a planet's surface. On geological timescales, impact events are inevitable. The same process that once built worlds continues to shape them, carving craters on moons and sending shockwaves through atmospheres. When we look at the smooth arcs of the planets today, we are seeing the survivors of an ancient battlefield, worlds that endured countless collisions to arrive at balance. Their scars may be hidden beneath oceans or veiled by clouds, but the memory of those impacts lingers everywhere. The solar system's serenity is not the absence of violence, it is the peace that follows it. The calm after eons of fire, when gravity's long war gave way to harmony. And in every meteor that flashes across our sky, we still hear the faint echo of those collisions, the quiet memory of creation itself. Some astronomers propose that deep below the galactic plane, the Sun may once have had a binary companion, a faint star whose distant orbit could explain periodic extinctions on Earth. It's a haunting idea that our Sun, bright and life-giving, was not always alone. In the early days of star formation, binary systems are common. Two suns born from the same cloud of gas and dust, bound together by gravity. Perhaps, long ago, our Sun had a partner. Small, dim, and wandering, and over billions of years, that second star drifted away into the black. This hypothetical companion has a name: Nemesis. A poetic title for a ghost star that might once have shaped the rhythms of life and death on Earth. The theory suggests that Nemesis, orbiting far beyond the Oort Cloud, could have passed through dense regions of space or disturbed the cloud itself every 26 million years or so, sending waves of comets hurtling inward toward the inner solar system. Some of those comets, colliding with Earth, might have triggered mass extinctions, including the one that ended the age of the dinosaurs. It's a pattern that some researchers once thought they saw written in the fossil record, a periodic rise and fall of biodiversity, echoing over geological time. Could that rhythm be the gravitational whisper of a lost star? If Nemesis existed, it would have been faint, perhaps a red dwarf or a failed star known as a brown dwarf. Too dim to see with the naked eye, yet massive enough to tug at the Sun's outer regions. Over the eons, the gravitational tides of the Milky Way might have stretched and warped its orbit, eventually pulling it so far away that the bond between the two stars broke. Nemesis, if real, could now be drifting through interstellar space, a rogue sun without a system, lost to the galaxy's vast current. Despite decades of searching, no clear evidence of Nemesis has ever been found. Infrared surveys like WISE have scanned the sky in exquisite detail, ruling out any companion within a light year of the Sun, bright enough to fit the theory. And yet, the mystery remains. Detached worlds like Sedna and the peculiar clustering of some distant trans-Neptunian objects hint that something massive may still lurk far beyond Pluto's orbit. Whether it's a planet or a faint star, no one can yet say. If Nemesis was real, it would mean our solar system was born as a duet, a pair of stars orbiting together through the galaxy's infancy. One remained at the center, nurturing life. The other drifted into exile, invisible yet influential, shaping the solar system's outermost reaches from afar. And if it was never real, the myth itself still teaches something profound. That even our star, so constant and familiar, may once have been part of something larger, reminding us that isolation is an illusion, and that in the story of the cosmos, every light has its counterpart. The sun's dark twin may never be found. It may exist only as an echo of curiosity, a mirror for our search for origins and endings. But somewhere in the depths of the galaxy, among the countless faint stars drifting in solitude, perhaps one still carries the quiet memory of our sun, a twin separated by time, distance, and destiny, forever circling the same galactic heart. Interstellar objects like Oumuamua and Borisov arrived from beyond the solar system, slicing through our cosmic neighborhood. Each may carry secrets from other stars, fragments of alien systems drifting among us. For the first time in human history, we have witnessed true interstellar travelers, objects not born of our sun, but of other suns, other worlds, other beginnings. In 2017, astronomers spotted a faint, tumbling speck of light moving far too fast to be bound by the sun's gravity. It came from the direction of the constellation Lyra, curved briefly around our star, and vanished into the dark. We named it Oumuamua, Hawaiian for scout or messenger from afar. Its shape was unlike anything we had ever seen. Long and thin like a needle, or perhaps a flattened shard, Oumuamua reflected sunlight erratically, tumbling end over end. It accelerated slightly as it left the solar system. Not from engines or intent, but perhaps from invisible jets of vapor or the gentle push of sunlight on its thin surface. Some scientists saw it as a fragment of a shattered planet, a splinter flung across light years. Others whispered it might be something stranger, a relic of alien engineering drifting powerless through space. 2 years later, another interstellar traveler appeared, Comet Borisov, this time unmistakably a comet, complete with a glowing coma and tail. It moved faster than any comet ever recorded, its chemistry revealing a mix of ices and dust born around another star. For the first time, humanity was able to study in detail material that formed in an entirely different solar system. These visitors are more than curiosities, they are messengers. Each carries within it the story of another sun's creation, the chemistry of distant worlds, and the fingerprints of processes that shaped stars light years away. They prove that solar systems are not isolated islands, but part of a galactic ecosystem where matter is shared, exchanged, and recycled over eons. Scientists believe there may be trillions of such objects drifting silently through the galaxy. Chunks of rock and ice ejected by forming planetary systems, wandering forever between the stars. Occasionally, by chance, one passes close enough to be caught briefly in our sun's light before vanishing again into eternity. Most go unnoticed, but each is a thread in the web of galactic connection, a traveler linking one cosmic story to another. Perhaps one day we will send probes fast enough to chase them, to intercept an interstellar object and sample its dust, its molecules, its memory. For now, we can only watch as they pass. Uninvited guests moving through our front yard. Their paths a reminder that the solar system itself is not fixed, but open. Oumuamua and Borisov were the first we've seen, but not the last. Even now, others are on their way, silent, invisible, cutting through the outer darkness. They may come from stars long dead, from systems newly born, from places we will never reach. Each one carries a fragment of another world, another story, another beginning. And for a brief moment, as they pass through our sun's faint light, those stories touch ours, then continue on, vanishing into the endless dark, leaving only a whisper of motion behind. Above the solar system, magnetic fields weave through the interstellar medium like silk threads in the dark. They guide cosmic rays, sculpt the heliosphere, and shape how energy moves through space itself. Space may seem like a void, but it is far from empty. Between the stars lies a delicate tension, a web of invisible force lines stretching across light years, twisting and folding through clouds of gas, dust, and plasma. These are the magnetic fields of the galaxy, subtle yet powerful, threading the cosmos like unseen architecture. They are the reason cosmic particles move as they do, the reason energy can ripple across the vastness without a sound. The Sun, too, contributes to this magnetic fabric. Its magnetic field, carried outward by the solar wind, inflates the heliosphere, a great bubble of charged plasma that envelops all the planets. Where the heliosphere meets the galactic field, the two interact, merging and contorting like interlocking waves. The boundary between them is not clean, but a turbulent veil, a shifting membrane where solar and interstellar magnetism wrestle for dominance. This magnetic veil protects us. It deflects most of the high-energy cosmic rays that race through the galaxy, particles born from supernovae and black hole jets. Without it, Earth would be bombarded by radiation far too intense for life to survive. The magnetic field, though invisible, is as vital as the atmosphere we breathe, a silent guardian surrounding our entire planetary system. Yet it also connects us to the larger galactic field. Where the Sun's influence wanes, the Milky Way's magnetism takes over, guiding the charged particles that drift through interstellar space. These fields are not uniform. They twist around molecular clouds, bend through spiral arms, and ripple like auroras stretched across the void. The galaxy itself is magnetized, its fields shaping the birth of stars and the motion of cosmic dust. When Voyager 1 crossed the heliopause in 2012, its instruments detected a faint but distinct change in direction, proof that it had entered a new magnetic domain. Beyond that point, the spacecraft no longer felt the Sun's magnetic pull. It was now drifting through the galactic current, tracing the lines of force that extend across the stars. If we could see this magnetic veil, it would shimmer like a luminous tapestry, filaments of energy looping and spiraling through space, glowing faintly where charged particles race along them. Above and below the solar system, these filaments form vast sheets and waves, connecting our Sun to the larger structure of the Milky Way. They are the unseen scaffolding of our galaxy, the framework that holds cosmic matter in place. Magnetic fields do more than guide motion, they give the universe texture. They allow galaxies to breathe, shaping how stars form and how cosmic rays wander. Even here on Earth, they influence the rhythm of the auroras, the flow of radiation, the compass of life itself. So when we gaze upward and see nothing but darkness, remember that beneath that darkness lies a lattice of lightless threads, magnetic pathways stretching across infinity. We cannot see them, yet we are wrapped within them. The solar system sails through their patterns like a ship through unseen tides, its course guided by forces as old as the galaxy itself. The magnetic veil is the quiet pulse of the universe. Everywhere, unbroken and eternal. The very dust we breathe once drifted from ancient supernovae. Some isotopes buried in Earth's crust still carry traces of explosions that occurred just above the solar system a few million years ago. Every element heavier than hydrogen was forged in the heart of a dying star. When those stars exhausted their fuel, they collapsed under their own gravity and detonated in cataclysmic bursts of light, supernovae, bright enough to outshine galaxies. These explosions scattered the raw materials of life, carbon, oxygen, iron, into space, where they drifted through the galaxy, eventually coalescing into new stars, new planets, and new beginnings. We are made, quite literally, from the ashes of those long-dead suns. But the ghosts of those explosions still linger near us, written in the chemistry of our world. In the deep layers of Earth's crust and in ancient seabed sediments, scientists have found traces of rare isotopes, iron 60, plutonium 244, and others that could only have come from nearby supernovae. These radioactive fingerprints suggest that between 2 and 3 million years ago, a massive star just a few hundred light-years away met its end. The shockwave from its death would have rippled through the local bubble, the vast low-density cavity of hot gas in which our solar system now drifts, perhaps even shaping the heliosphere itself. Imagine the sky then, a brilliant star blooming suddenly in the night, visible even in daylight for weeks. Its light would have bathed Earth in cosmic radiation, altering the atmosphere, perhaps even leaving subtle marks on the planet's biosphere. Though the effects on life were likely minor, The evidence of that stellar death remains, a silent cosmic residue beneath our feet. The solar system itself may have been born from such a death. Astronomers believe a supernova explosion triggered the collapse of the gas cloud that formed the Sun, injecting freshly forged elements into the nebula that became our home. Every breath we take carries atoms that were once part of a star's final exhalation. Even now, the Milky Way's spiral arms are dotted with the remnants of such cataclysms, glowing shells of gas expanding through space, their shockwaves sweeping up dust, compressing it, and planting the seeds for the next generation of stars. This cycle of destruction and creation is the heartbeat of the cosmos, death giving way to light, chaos giving birth to form. The traces of past explosions that reach us, those faint isotopes locked in stone, are whispers of that grand cycle. They tell us that our solar system does not drift through a dead galaxy, but through one still alive with energy and memory. The very dust that floats in our atmosphere, the iron in our blood, the calcium in our bones, all of it came from such stellar ghosts. Above and below the solar system, drifting through the interstellar medium, are clouds of dust still glowing faintly from ancient supernovae, remnants of stars that died to make space for us. And though they are invisible to the eye, their presence is everywhere, in the air we breathe, in the oceans, in the earth itself. We live surrounded by ghosts, and those ghosts are made of light. Our solar system isn't floating in emptiness. It's sailing through a region known as the local bubble, a vast cavity carved by multiple supernovae. Its edges glow faintly in X-rays, like a cosmic reef made of light. For most of human history, we imagined space as endless and uniform, an infinite void without pattern or boundary. But the more we've observed, the more we've discovered that even emptiness has structure. Our sun and its planets drift not in open space, but within a bubble, a pocket of thin, hot gas surrounded by denser clouds. This bubble is our neighborhood, and its story begins in violence. Around 10 million years ago, a chain of massive stars near what is now the constellations Scorpius and Centaurus reached the ends of their lives. One by one, they exploded as supernovae, their shockwaves carving overlapping cavities in the surrounding interstellar medium. Over time, these expanding shells merged into a single irregular void roughly 1,000 light-years across. That's the local bubble, a glowing scar in the Milky Way's spiral arm, created by fire and sustained by light. Inside it, the interstellar gas is astonishingly thin, so sparse that a cubic centimeter contains fewer atoms than a vacuum chamber on Earth. Yet this near emptiness is filled with high-energy plasma, heated by ancient explosions to millions of degrees. The bubble's boundaries, meanwhile, are rich with cooler gas and dust, compressed into bright glowing filaments by the force of the supernova blasts. These edges shimmer faintly in ultraviolet and X-ray light, wrapping around our solar system like a luminous shell. If we could step outside the Milky Way and look back, the local bubble would resemble a vast translucent cavity, its walls glowing with the faint light of ionized atoms, its interior nearly transparent. Within it, we are like divers swimming in a hollow reef, our sun one of many stars moving through its interior currents. Other stars, too, drift within this same cavity, most notably the young cluster known as the Pleiades Moving Group, whose members light the bubble from within like lanterns suspended in glass. The edges of the local bubble are not static, they are alive. Stellar winds and magnetic fields push against its walls, causing ripples that slowly change shape over millions of years. As nearby stars form, burn, and die, new energy flows into the cavity, renewing it. And someday, when another wave of supernovae occurs nearby, the bubble may expand again or collapse entirely into the surrounding clouds. Recent observations even suggest that our sun entered the local bubble only a few million years ago, perhaps around the same time those supernovae showered Earth with iron 60. If true, it means we are still travelers moving through the lingering echo of those stellar deaths. The radiation that shaped this region may have also shaped the path of life on Earth. This galactic reef, glowing faintly in X-rays and starlight, is not a boundary, it's a reminder of connection. Every breath of gas, every flicker of light in this region once belonged to stars that lived and died long before our sun was born. We drift within their legacy, surrounded by the beauty of their destruction. The local bubble is our home within a home, a fragile, radiant hollow carved into the galaxy's vast sea. And as the solar system sails through its depths, we are reminded that even in apparent emptiness, the universe still remembers its own creation. Below the heliopause, temperatures plunge to near absolute zero. Here, molecules freeze mid-motion, and the faint hum of cosmic background radiation is the only remaining heat. Beyond the warmth of the sun, beyond even the reach of its fading wind, lies a region of silence so deep that heat itself seems to die. This is the cold frontier, the outermost edge of the solar system, where energy thins, motion slows, and the universe begins to reveal its ancient stillness. Out here, sunlight is little more than a distant memory. What reaches these depths is not warmth, but whisper. Photons spread so thin that they barely illuminate the dust. The space between particles stretches wide, the gas grows rarefied, and the temperature hovers just a few degrees above absolute zero, the cosmic baseline, set by the faint glow of the Big Bang itself. It is a realm where even the definition of cold changes. At such extremes, atoms move so sluggishly that time feels suspended. Molecules that would dance freely in the air on Earth are locked into motionless ice, and any spacecraft daring to enter this void must guard its instruments against the freezing grip of emptiness. Even the radiation from nearby stars cannot easily pierce this veil. It is a place ruled by stillness, darkness, and the endless quiet of deep space. The only warmth here comes from the cosmic microwave background, the residual glow left over from the birth of the universe nearly 13.8 billion years ago. That light, stretched into long invisible waves by the expansion of space, bathes everything equally. It is the faintest possible fire, 2.7 degrees above absolute zero, filling the cosmos like an ancient heartbeat that never fades. For billions of years, the cold frontier has remained unchanged. Comets drift through it like frozen ghosts, their orbits so vast they only glimpse sunlight once every few million years. Dust from the Oort Cloud slowly spirals inward, sometimes awakened by distant gravitational nudges, but most remains forever lost to the dark. This region is where the solar system finally dissolves into the galaxy, a boundary not marked by light, but by the absence of it. If you could stand on a comet here, the sun would appear smaller than any other star in the sky, just another point of light among billions. You would feel no warmth, no wind, no sound. Even your breath would crystallize in an instant. Only the faint hum of the universe itself would remain, washing over you like a memory of creation. The cold frontier is not empty. It is full of everything that once was. Ancient dust, frozen gases, and atomic remnants drift through it, preserved like fossils in time. Each particle carries the story of the solar system's formation, untouched since the dawn of the sun. This is the quietest place we know, the threshold between the solar system's breath and the galaxy's chill. Beyond this frontier, the warmth of home fades completely, and the long silence of interstellar space begins. It is here, in the dark beyond sunlight, that the solar system ends and eternity begins. At the solar system's edge, time slows. The sun's gravity gently warps space-time, bending the path of light and altering how seconds pass. The farther we drift, the older the starlight becomes. To most of us, time feels constant, an invisible rhythm that moves forward at the same pace, no matter where we are. But in truth, time is elastic. It stretches and contracts under the influence of gravity and motion, rippling subtly through the fabric of reality. Near massive bodies like the sun, time passes ever so slightly slower than it does farther away. This means that the outer planets, Uranus, Neptune, and beyond, exist in a gentler flow of seconds, where each heartbeat ticks infinitesimally faster than those felt here on Earth. It's a difference so small it seems meaningless, yet in cosmic terms, it speaks volumes. At the distance of Uranus, nearly 3 billion kilometers from the Sun, the distortion of time is imperceptible to human senses but very real to physics. Clocks would run just a fraction of a second faster, but that fraction, multiplied by billions of years, becomes a subtle divergence between what is now and what was. The light we see from Uranus is not a moment, it's a message delayed by nearly 3 hours, the time it takes for sunlight to reach and return. In every glimmer, we're seeing not the present, but the past. The deeper one moves into the solar system's outskirts, the more reality itself begins to bend. Light fades. Radio waves stretch. Time becomes less a constant and more a landscape, warped by the gravitational presence of the Sun and the slow, steady motion of the planets. In the vast space between worlds, the difference between 1 second and the next depends on where you stand. Closer to the Sun, time is heavy and slow. Farther out, it becomes lighter, freer, moving toward the infinite calm of interstellar space. For any future probe journeying toward Uranus, this quiet distortion will be its first brush with the strange relativity of the cosmos. Each moment aboard will tick ever so slightly faster than moments on Earth, meaning the spacecraft's onboard clock will age ahead of us, even as it moves farther into the past light of the Sun. The farther it travels, the greater the divide between our seconds and its own. Time, it seems, has borders, subtle thresholds that separate one rhythm of existence from another. At the edges of our solar system, time loses its human definition. There are no days, no months, no familiar cycles. A Uranian day lasts 17 hours. A Uranian year spans 84 Earth years. Seasons stretch across generations. A single sunrise could outlive you, and a single sunset might mark the passage of an entire human civilization. Time there isn't measured by clocks. It is measured by motion, by silence, by distance. When we look at Uranus through our telescopes, we are not seeing it as it is, but as it was, a younger version of a world that has already moved on. Every storm we detect is history still travelling toward our eyes. In that sense, Uranus doesn't just exist in space, it exists across time. It is both present and past, still and moving, a pale world gliding through an ocean where even seconds drift like dust. And when we gaze toward that frozen horizon, we are reminded that time is not a river flowing evenly forward. Beyond Uranus, the tide grows calm, the light grows ancient, and somewhere out there, past the invisible line where the sun's gravity begins to fade, lies the boundary of time, the place where the solar clock finally stops ticking and eternity begins to hum. Beyond Neptune, small icy moons orbit forgotten dwarf planets, worlds of methane, frost, and frozen nitrogen. Each one glimmers faintly in reflected sunlight, unseen except by the most powerful telescopes. Out there, in the dim frontier where the sun is little more than a bright star, the familiar order of the solar system dissolves. The great planets end, and something quieter begins, a realm of shadows and fragments, where ancient worlds drift in silence. This is the Kuiper belt, a vast ring of icy bodies encircling the sun beyond Neptune's orbit. It is the graveyard of creation, the frozen debris left over from the birth of the solar system. And within it, small moons orbit even smaller worlds, silent companions circling through endless night. Some of these moons are so faint that they escaped discovery until recently. They shine only by the weakest reflection of sunlight, glowing like dust against the infinite black. Around Pluto, 5 small moons dance in chaotic resonance, tumbling unpredictably as they orbit their frozen parent. Farther out, around Eris, Haumea, and Makemake, dwarf planets as strange as their names, tiny moons glide in slow motion, their surfaces locked in ice for billions of years. Each one is a relic of collisions long past, fragments that refuse to fade completely into the void. If you could stand on one of these moons, you would see the sun as a pinprick of light, so distant you could blot it out with your thumb. The sky would be filled not with bright stars, but with faint whispers, distant suns scattered across eternity. The cold would be absolute, colder than any desert of the inner planets, where nitrogen turns solid and methane forms glittering frost across the ground. A world frozen in stillness, where a single orbit might take centuries to complete. Astronomers believe many of these moons, and even the dwarf planets they orbit, are leftovers from the same ancient collision era that tilted Uranus. In the early days of the solar system, chaos ruled. Protoplanets collided and shattered, scattering their fragments outward into the deep. Some of those fragments coalesced into moons, others drifted away into the Kuiper belt, where they have remained ever since, preserved in ice and memory. To study them is to look backward through time, to glimpse the raw materials from which all planets were made. The New Horizons mission, which flew past Pluto in 2015, revealed how hauntingly alive these frozen worlds can be. Mountains of ice, plains of nitrogen, and signs of slow geological movement, all sculpted by frozen chemistry and the faint heat of radioactive decay. Even in this outer darkness, change persists. The hidden moons, though small, may shape their parent worlds through tides and impacts, carving subtle patterns that only long-term observation can reveal. Beyond them, there are likely countless others, moons we haven't yet seen, orbiting bodies we don't yet know exist. The Kuiper belt may contain hundreds of thousands of such systems, tiny kingdoms of ice and stone circling in the dark. Each one moves to its own rhythm, untouched by sunlight, governed only by gravity and the slow drift of cosmic time. In the deep, where the sun's warmth is just a memory, these hidden moons remind us that even at the edge of creation, companionship endures. Every great planet has its retinue, every dwarf its moon, every fragment its story. They are the quiet witnesses of the solar system's ancient violence, still circling, still reflecting faint sunlight into the void, like the last whispers of a dawn long gone. The Kuiper belt hums softly in radio frequencies, filled with billions of minor bodies tracing ancient orbits. Together, they tell the solar system's oldest story, how chaos cooled into harmony. Beyond Neptune, space does not end, it simply fades. The light dims, the warmth vanishes, and the sun becomes a cold white star suspended in an endless dusk. Here, the solar system loses its boundaries, dissolving into a vast frozen field of debris, the Kuiper belt. It stretches from about 30 to over 50 astronomical units from the sun, a cosmic hinterland made of ancient leftovers. These are the remnants of planetary creation, untouched for billions of years. Every rock, every icy fragment, is a syllable in the story of how order emerged from chaos. To most telescopes, the Kuiper belt is invisible, a faint halo of motion against the infinite black, but to radio antennas and deep space sensors, it sings. The belt emits a faint hum, not from its own voice, but from the countless collisions and interactions of particles orbiting the sun. It is a whisper of static, a background rhythm that tells astronomers where the solar system ends and the interstellar medium begins. Like the fading heartbeat of a once chaotic cosmos, the Kuiper belt's radio echo reminds us that even silence can carry history. This region is home to dwarf planets like Pluto, Eris, Haumea, and Makemake, each one a frozen remnant of a time before Earth had oceans or air. Their surfaces are covered in methane frost, nitrogen glaciers, and patches of organic compounds called tholins, formed when ultraviolet light breaks apart simple molecules and rebuilds them into darker, redder ones. These same tholins may have seeded the chemistry of life in the early solar system, drifting inward on comets that carried their cargo to a young Earth. In that sense, the Kuiper belt is not just a graveyard, it's also a cradle where the ingredients of life may have first taken shape. Between these worlds drift countless smaller bodies, comets, shards of rock and ice, and invisible grains of dust. Occasionally, a gravitational nudge from Neptune or a passing star sends one of these wanderers inward, beginning a long journey toward the sun. As it warms, it sheds its icy shell, forming the glowing tail we recognize as a comet. Every comet we see is a message from the Kuiper belt, a visitor from the solar system's memory. And yet, Despite being so remote, the belt's influence reaches far beyond its frozen horizon. Its mass, though scattered, subtly affects Neptune's orbit, pulling and pushing in minute, measurable ways. Some scientists even believe an unseen planet, a massive body hidden deep within the belt, could be shaping its outer edge, shepherding debris into the strange patterns we observe. If such a world exists, it may be the 9th planet, orbiting far beyond the known, cloaked in perpetual darkness. In many ways, the Kuiper belt is the solar system's library of time. Every object within it preserves the conditions of the early nebula. The mixture of gases, dust and ice that formed the Sun and its planets. Unlike Earth, which has been reshaped by tectonics and life, to study them is to look backward through billions of years, reading the pages of a story written before humanity, before even the Earth itself existed. So when radio astronomers tune their antennas toward the edge of the solar system, the faint static they detect isn't just noise. It's the whisper of the Kuiper belt, the collective murmur of billions of ancient fragments, circling endlessly through a realm where the sun's light fades but never truly dies. It's the sound of time itself cooling, the echo of creation settling into peace. A whisper, older than life, still drifting through the dark. Some models suggest a flow of dark matter passes directly through the solar system. Though we cannot see it, it may subtly tug on planets, bend light, and even flow through our own bodies every second. Imagine the solar system not as an island adrift in empty space, but as a ship sailing through an invisible current. A river of something we cannot see, cannot touch, yet know must be there. This is the dark matter halo, an unseen ocean of mass that surrounds our galaxy, stretching far beyond the reach of starlight. We drift within it unknowingly, every moment of our lives. Every orbit, every rotation, every second of time unfolds within this hidden sea. Dark matter makes up nearly 85% of the total mass of the universe, yet it neither emits nor absorbs light. To our telescopes, it is utterly invisible. We know it exists only because of the way it bends gravity, how it tugs on galaxies, how it sculpts the motions of stars. Without it, galaxies would fly apart. Without it, the cosmos as we know it could not exist. It is the scaffolding upon which all visible matter hangs, the silent architect of the universe. And right now, a river of it flows through us. Our solar system, orbiting the center of the Milky Way, moves through this dark matter halo at about 230 kilometers per second. As we travel, the planets, the sun, and even our own atoms pass through an invisible wind of dark matter particles, streaming like ghosts through everything that exists. They pass through the walls of your home, through your skin, through the iron in your blood, and continue out the other side without leaving a trace. Every second, trillions of these particles drift through your body, unnoticed, undetected, and unstoppable. Scientists have spent decades trying to catch them. Deep underground, in laboratories shielded from cosmic radiation, detectors filled with liquid, xenon wait in silence. Occasionally, a single dark matter particle might strike an atom in the detector, releasing a tiny flash of light, a whisper of the unseen. Yet so far, the universe has kept its secret. Each experiment has ended in silence, as though the river refuses to reveal its presence. Some theories suggest that dark matter could gather in subtle ways, clumping around massive bodies like the Sun, the gas giants, or even Uranus itself. If so, it might slightly alter their orbits, imperceptibly, but measurably, over millions of years. Perhaps the cold mystery of Uranus, its missing heat, its uneven magnetism, its faint gravitational quirks, are all whispers of this hidden current passing through it. Maybe the planet's stillness is not absence, but equilibrium. A balance between the matter we can see and the matter we cannot. Other physicists think of dark matter as something far stranger, fields instead of particles, rippling through space like unseen tides. In this view, the solar system floats through waves of density and emptiness. its planets rising and falling within the gravitational rhythm of a dark ocean. If true, every orbit, every spin, every second of celestial motion is subtly sculpted by a hand we can never grasp. And perhaps that's the true beauty of it. That even as we map the visible universe in exquisite detail, there remains something profoundly unknowable, something surrounding us, shaping us, carrying us along. The dark river below flows silently, patiently, endlessly. We may never see it, but we are part of it. Every planet, every star, every one of us drifts within its current, moving together through an ocean of shadow, the invisible backbone of everything that has ever been and everything that ever will be. Every day, hundreds of tons of cosmic dust rain upon Earth from above. Microscopic grains of ancient stars settle on our oceans and mountains, a silent drizzle from the heavens. We rarely think of it, but the air we breathe is filled with fragments of space. Every sunrise filters through clouds of dust that were born before the sun itself. Every night, unseen particles drift down upon us, grains no larger than a strand of hair, travelling millions of years across the dark to finally rest upon our planet. These are the ashes of creation, falling quietly, endlessly, through the thin blue veil of our atmosphere. This rain of stardust never stops. Scientists estimate that about 40,000 tons of cosmic material enter Earth's atmosphere each year. Most of it is too small to burn up, as shooting stars. Instead, it flutters downward, slowed by air resistance, surviving the journey as microscopic specks that gently land on rooftops, deserts, and deep-sea floors. If you've ever brushed dust from a windowsill, you may have unknowingly swept away the remnants of a star that exploded before our species existed. Each grain tells a story older than Earth itself. Some are fragments of comets, shattered as they neared the sun and released trails of ice and dust. Others are remnants of asteroids, broken pieces of rock and metal left over from the solar system's formation. But some particles are far more ancient, forged in the dying hearts of distant stars. When those stars exploded as supernovae, they hurled their elements into space: carbon, silicon, iron, gold. Over time, these particles wandered through interstellar space, were gathered into new solar systems, and now, billions of years later, have found their way home to us. Scientists collect these cosmic grains from the most remote places on Earth: the icy plains of Antarctica, the peaks of mountains, the depths of the ocean. There, untouched by modern pollution, the dust lies preserved, each particle a message from the deep past. When examined under microscopes, they reveal astonishing details: tiny crystals of olivine and pyroxene, spherical glassy shells, traces of rare isotopes that betray their stellar origins. These grains are, in every sense, fossils of the universe's infancy. And within them lies a humbling truth: the building blocks of everything we know, planets, oceans, and even life itself, were once part of this same cosmic rain. Long ago, the dust that now settles on our windows once settled on the young Earth, seeding its oceans with the carbon and oxygen that would one day form living cells. Each new layer of dust is both an ending and a beginning, a slow reminder that creation is a cycle without end. Even now, as you read these words, cosmic dust is falling through the air around you. It drifts silently through your home, onto your hands, into your breath. You are surrounded, constantly, by the universe's remnants. Every moment, Earth is gently reconnecting with the cosmos that made it. The next time you see sunlight streaming through a window and illuminating tiny motes of dust, remember, many of those motes are older than the Earth itself. They were born in the hearts of stars, scattered across galaxies, and carried here by the slow, endless tides of space. The cosmic downpour never ceases. It is the universe's quiet way of touching us, of reminding us that we were never separate from the stars. We have always been their dust, simply fallen home again. If we could see our system from afar, it would look like a glowing disk surrounded by a halo of dust, an echo of creation still shimmering around the sun. From the vantage point of deep space, the solar system is not a collection of isolated planets, but a single luminous structure, a flattened sea of light and dust swirling around a central fire. Each grain, each particle, each frozen shard of rock reflects a faint glimmer of sunlight. Together, they create what astronomers call the zodiacal cloud, a vast veil of microscopic debris that fills the inner solar system like cosmic mist. It's what makes the night sky glow faintly before dawn or after sunset, that ghostly shimmer known as the zodiacal light. This halo of dust is our reflection, the solar system's faint echo, a portrait painted in scattered sunlight. To an observer light years away, our sun would appear as an ordinary star, but its glow would be wrapped in a subtle haze, like breath on glass. Through that haze, a careful observer might notice the delicate, circular ripple of planets orbiting, a family of worlds moving in harmony through their luminous cradle. Most of this interplanetary dust is ancient, remnants of the same material that formed the planets themselves. Billions of years ago, the solar system was nothing more than a rotating disk of gas and particles surrounding a newborn sun. Over time, gravity pulled the largest fragments together to form planets, while smaller pieces remained adrift, trapped in eternal orbit. Even now, collisions between asteroids and comets refresh this cloud, releasing new grains into the void, each one glinting for a moment before it fades into the dark. But this reflection does more than shimmer. It tells a story. The shape of the zodiacal cloud reveals the hidden architecture of our system. By studying how light scatters off these particles, astronomers can trace where dust is thickest, where comets shed their tails, and even where unseen asteroids linger. It's as though the solar system leaves fingerprints in light, revealing the invisible through its faintest traces. Some of the most distant exoplanetary systems we've observed also display these luminous halos, rings and belts of dust circling their stars. In a way, they're mirrors of our own system's youth. When we look at them through telescopes like James Webb, we are seeing echoes of what our solar system once was, a swirling, glowing cradle of matter from which worlds were born. And just as we look outward, others, if they exist, could look inward. If an alien civilization far away pointed its instruments toward our sun, they might see that same soft glow and wonder what lies within. They might notice the rhythmic dimming as Earth and its siblings pass before the sun, tracing faint shadows across that light. Perhaps they would realize that our small blue world orbits there, an island of water and life, hidden within a sea of dust and gold. The solar system's reflection reminds us that we are luminous beings in a luminous place. Even from the vast distances between the stars, our home shines faintly, wrapped in a delicate halo of memory, a reminder that the materials which formed us still drift through the same cosmic sea. If we could see our world from afar, we might realize something profound, that the solar system is not just a collection of planets and moons, but a living mirror of its own creation, a reflection of the light that first gave it life. Still shimmering quietly, forever. Some astronomers believe a ninth planet, massive and distant, lurks far below the plane of the known solar system. Its gravitational shadow could explain the strange orbits of dozens of icy bodies. It's a mystery at the edge of everything. A world that may exist, unseen, tugging softly on the architecture of our solar system. Beyond Neptune, beyond the frozen frontiers of Pluto and the Kuiper belt, something seems to pull. Tiny worlds, their orbits stretched into long, elegant ellipses, all tilt in the same direction, as though obeying an invisible hand. For years, astronomers dismissed it as coincidence, but the evidence kept growing, and now, some whisper of a ghost planet, Planet 9, a giant cloaked in darkness, moving through a realm where the sun is just another star. If it exists, this lost planet is nothing like the worlds we know. It may be 10 times the mass of Earth, orbiting the sun at a distance so vast that a single year there could last more than 10,000 of hours. It would take centuries for sunlight to reach its distant skies. Its orbit might carry it so far into space that the Milky Way itself becomes brighter than the sun. There, warmth is a memory, and the vacuum of interstellar space begins to whisper. The first clues came not from telescopes, but from patterns. In the 2010s, astronomers noticed that several distant Kuiper belt objects, like Sedna and 2012 VP113, shared oddly aligned orbits, all pointing in roughly the same direction in space. Their clustering defied statistical chance. Something massive, something unseen, was shepherding them, keeping them in formation. The simplest explanation was gravity, the pull of a planet we had not yet found. Simulations began. When astronomers modelled a hypothetical planet, 5 to 10 Earth masses, orbiting on an inclined, elongated path, they found the results matched reality. The hidden world would explain the strange tilt of the Sun's axis, the unusual clustering of faraway orbits, even the chaotic motion of some comets. It would also restore, in a poetic way, the symmetry that Uranus once disrupted. But finding it has proven nearly impossible. At such a distance, the planet would be hundreds of times fainter than Pluto, barely distinguishable from the background stars. It could be hiding in the dense star fields of the Milky Way, its slow motion nearly imperceptible. Even with our most powerful telescopes, like Subaru in Hawaii or the Vera C, Rubin Observatory now coming online, spotting it would be like finding a single grain of sand drifting in a sea of starlight. Some scientists argue that the alignment of those icy bodies could be the result of statistical bias or even the gravitational influence of the collective Kuiper belt itself. Others are convinced that the evidence points to something real. Something waiting out there in the shadows, moving too slowly to reveal itself. And if it does exist, what then? It could be a rogue planet, captured by the Sun's gravity long ago, a wanderer from another star system. Or perhaps it formed alongside the others, only to be flung outward in the solar system's violent youth, forever exiled to the outer dark. In either case, it would be a survivor, a relic of creation, orbiting unseen through the interstellar twilight. The lost planet, real or imagined, reminds us how incomplete our understanding still is. For all our telescopes and mathematics, we have explored only a thin sliver of the space around us. Beyond that lies mystery, waiting to be named. And somewhere out there, perhaps in the quiet darkness beyond the Kuiper belt, a massive world continues its silent orbit, its shadow tugging at the orbits of everything we know, its existence a whisper, just beyond the reach of light. Beneath every orbit lies a connection. Jupiter's mass tugs on Earth, Earth tugs on the Moon, and together they tug on the Sun. The entire system is a delicate balance, held by unseen threads of attraction. Though we often imagine the solar system as a hierarchy, the Sun commanding, the planets obeying, the truth is far more intricate, far more poetic. Every planet, every moon, every drifting grain of dust participates in that dialogue, pulling ever so slightly on everything else. The result is not a static system, but a symphony, a vast web of motion in which every note influences the next. When Newton first described gravity, he revealed that every object in the universe attracts every other object with a force proportional to its mass and inversely proportional to the square of their distance. It sounds simple, but from that single principle emerges the choreography of the cosmos: orbits, tides, resonances, and the invisible tethers that link worlds together across billions of kilometers. Take Jupiter, for example, the solar system's great anchor. Its immense mass exerts a gravitational influence that reaches far beyond its orbit, subtly guiding the paths of asteroids, steering comets, and even shaping Earth's history. Without Jupiter, the asteroid belt might have coalesced into another planet. Or, perhaps, Earth itself might have endured far more frequent catastrophic impacts. In that sense, Jupiter is both protector and disruptor. Its pull a cosmic heartbeat that keeps the inner planets in rhythm. Even the Sun is not truly still. Though it outweighs all the planets combined, their collective gravity causes it to move, tracing small graceful loops through space as it responds to the combined pull of its children. The solar system's true center of mass, called the barycenter, sometimes lies just outside the Sun's surface. In other words, the Sun itself orbits something too, the shared gravitational heart of its family. Every connection, every orbit, is part of this immense web. The Moon lifts Earth's oceans into tides. The Earth and Moon together tug on the Sun while the Sun's pull keeps them in orbit. Uranus and Neptune subtly disturb each other's paths, locked in a slow gravitational dance that takes centuries to unfold. Even Pluto, tiny and distant, plays its part, its orbit locked in a 3-to-2 resonance with Neptune's, ensuring they never collide despite their crossing paths. Gravity does not stop at planets. It threads through rings and dust, through the faint arcs of the Kuiper belt, through the delicate structures of Saturn's moons and the ripples in Uranus's rings. Each motion sends a tremor through the web, felt everywhere in tiny, imperceptible ways. If we could see gravity, the solar system would look nothing like the simple diagrams in textbooks. Instead, it would resemble a glowing tapestry of curved lines and shimmering threads, all converging and diverging in endless harmony. Each planet would drag behind it a wake of distortion, bending space-time as it moves, weaving patterns that stretch from the Sun to the edge of the heliosphere. Even we are caught in those threads. Every heartbeat, every breath, every grain of sand on Earth is part of that gravitational story. When you jump, you fall back not because of the Earth alone, but because the Sun and Moon and planets all agree on where you belong. Gravity is the quiet architect of everything, the invisible hand that binds chaos into structure. It is both the universe's greatest force and its most tender touch. And somewhere beyond Neptune, that same thread continues, unbroken, pulling on Uranus, on the comets, on the drifting dust that still carries the memory of creation. The web hums softly in the dark, keeping everything tied together, from the heart of the Sun to the coldest stone at the edge of forever. Above the solar system, high-energy cosmic rays bombard our magnetic shield. Each one carries the signature of events that occurred millions of light-years away. Space, though it seems silent and empty, is anything but still. The void between the stars is filled with an invisible rain, charged particles traveling at nearly the speed of light. Relics of explosions so distant that the galaxies which birthed them may no longer exist. These are cosmic rays, fragments of atoms stripped of their electrons and hurled across the universe by supernovae, pulsars, and black holes. They are the messengers of violent creation, drifting endlessly through the darkness. When these particles reach our solar system, they find themselves in the presence of a giant shield. The Sun, through its magnetic field and solar wind, inflates a vast bubble around us called the heliosphere, a magnetic cocoon stretching billions of kilometers into space. It deflects many of these cosmic rays, bending their paths, slowing their approach. Yet some still find a way through, slipping between the magnetic lines and striking the planets, the atmosphere, even us. Every second, cosmic rays collide with Earth's upper atmosphere, creating cascades of subatomic particles that rain down like invisible snow. You can't feel them, but they pass through your body constantly, millions of times each day. Most are harmless, dissipating their energy long before reaching the ground. But for those who venture beyond Earth's magnetic field, like astronauts, these particles become a dangerous storm, capable of damaging DNA and electronics alike. And yet, hidden within their danger lies wonder. Each cosmic ray is a traveler, a time capsule carrying information from across the universe. Some originated in distant galaxies, flung into motion by dying stars whose explosions outshone entire constellations. Others may have been accelerated by the magnetic fields of supermassive black holes, emerging from jets of plasma that stretch for thousands of light-years. The energy contained within a single cosmic ray particle can rival that of a baseball thrown by a human hand, concentrated into a single proton. When these particles strike detectors on Earth, they tell stories no telescope could. Scientists study their arrival directions, energies, and frequencies to map the invisible structures of the cosmos. The magnetic filaments between galaxies, the remnants of ancient stellar deaths, even hints of unknown physics. In a sense, cosmic rays are the universe's handwriting, etched into the fabric of space itself. But not all of them come from afar. Our own sun produces streams of energetic particles during solar flares and coronal mass ejections. These solar cosmic rays, while less powerful, shape our space weather and affect satellites, communications, and power grids on Earth. The balance between these local emissions and the interstellar bombardment creates an ever-changing ocean of radiation through which every planet swims. Uranus, distant and cold, drifts quietly beneath this storm. Its magnetic field, tilted and off-center, creates strange, shifting shields that may let cosmic rays penetrate in unpredictable ways. The planet's upper atmosphere, serene in appearance, might glow faintly as these invisible particles collide with its gases, producing auroras that flicker in colors no human eye has ever seen. When you look up at the night sky, you are not looking through emptiness. You are looking through a sea of motion, a tide of energy that connects every world, every star, every galaxy. The air around you is alive with particles that began their journey before humanity existed. We live within that ocean, protected, illuminated, and occasionally touched by the universe's oldest travelers. Each one is a whisper from the past, a note in a cosmic song that has no beginning and no end. The ocean of particles surrounds us always, unseen but eternal, a reminder that even the silence between stars is filled with life, movement, and memory. Voyager 1 and 2, now in interstellar space, detected a constant hum, an interstellar plasma glow. This faint, omnipresent sound marks humanity's first hearing of the galaxy's voice. More than 40 years ago, two small spacecraft left Earth on a journey that no one expected to last this long. Launched in 1977, Voyager 1 and Voyager 2 were built to explore the outer planets, Jupiter, Saturn, Uranus, and Neptune, and then, if fate allowed, to continue outward into the unknown. They carried cameras, sensors, and a golden record, an artifact of humanity's existence should anyone ever find it. Today, they drift farther from home than any object humanity has ever made. Both have crossed the boundary where the sun's influence ends, the edge of the heliosphere, and entered the realm between the stars. Out there, in the deep stillness beyond the planets, something unexpected awaited them, a hum. Not a sound in the way we hear it, but a vibration, a steady faint frequency picked up by their plasma wave instruments. This signal, scientists realized, was the music of the interstellar medium, charged particles vibrating in the thin plasma that fills the space between stars. It is the faint, continuous glow of the galaxy itself, the quiet breath of the Milky Way. Before Voyager's discovery, interstellar space was imagined as near-perfect emptiness. But what the spacecraft revealed was something else entirely. A vast ocean of ionized gas, magnetic fields, and radiation, all alive with energy. The hum that Voyager 1 detected in 2021 was a pure tone, steady and unwavering, like the background note of the universe. It drifts between 2 and 3 kilohertz, far below human hearing but rich with meaning. It told scientists that even far beyond the reach of the sun, the space between stars is not silent, it sings. This interstellar plasma glow is produced when waves of energy ripple through the thin gas between stars, regions where electrons oscillate in harmony. The tone remains nearly constant, suggesting that the plasma beyond our heliosphere is far denser than expected. For decades, scientists thought of interstellar space as a void, but Voyager proved that it's more like a gentle fog, thin, vast, and faintly luminous. Every flicker, every variation in the hum, reveals how that fog changes as the spacecraft drifts deeper into the galaxy's unseen sea. It's humbling to think that the first ears to ever hear the galaxy's song were not human, but mechanical, two tiny emissaries carrying the curiosity of an entire species. Their instruments, now powered by fading plutonium hearts, still listen, still whisper data across billions of kilometers of emptiness. Each signal takes over 22 hours to reach Earth, crossing distances so immense that our sun has already moved slightly through the Milky Way in that time. To scientists, the Voyager hum is more than sound. It is proof that humanity has crossed a threshold. We have left the cradle of our sun and touched the true expanse of the galaxy. And though the Voyagers continue onward into darkness, their faint transmissions, those thin lines of static and hum, remain a heartbeat between stars, a connection between what we were and what we might yet become. Someday, the Voyagers will fall silent. Their power will fade, their instruments freeze, and their signals vanish into the static of the cosmos. But the hum they revealed, the glow of the galaxy itself, will continue, eternal and patient, filling the interstellar sea. It is a reminder that even in the coldest, emptiest places, the universe still sings. The glow beyond is not silence. It is the sound of existence continuing, quietly, beautifully, forever. As the sun moves through the galaxy, it leaves behind a magnetic trail millions of kilometers wide, a fingerprint of its passage through cosmic space. The sun is not still. It drifts through the Milky Way at nearly 230 kilometers per second, carrying the planets, comets, and dust of the solar system along in its wake. From a galactic perspective, we are passengers on a great stellar ship, sailing through a sea of magnetic fields and interstellar gas. And like a ship, the sun leaves a wake, a vast magnetic footprint imprinted into the fabric of space itself. This invisible signature is called the heliotail, the trailing edge of the heliosphere, the bubble of charged particles inflated by the solar wind. As the sun moves through the galaxy, the constant stream of plasma it emits collides with the interstellar medium, forming a bow wave at the front and a long tapering tail behind. It's the solar system's magnetic shadow, stretching for billions of kilometers, curving gently through the galactic tide. If you could see it, the heliotail would resemble a glowing comet, with the sun at its head and twin streams of magnetic plasma flowing outward behind it. These streams twist and ripple like ribbons in a solar wind, carried by magnetic fields that spiral from the sun's poles. This structure marks where our star's influence fades, where solar particles lose their strength and merge into the great diffuse ocean of the galaxy. Every 11 years, as the sun's magnetic field reverses, the shape of this tail changes. It bends, splits, and reforms in intricate patterns, echoing the rhythm of the solar cycle. The Voyagers, drifting near the edge of this boundary, have begun to measure faint traces of it, tiny variations in magnetic field strength that hint at the immense structure surrounding them. Even now, long after leaving the planetary realm, they are still sailing within the sun's magnetic reach. This magnetic footprint tells a story of motion and time. For billions of years, the sun has orbited the galactic center, completing a single revolution every 230 million years. A cosmic year. With each orbit, it plows through different regions of the Milky Way, through clouds of dust, through arms of stars, through currents of interstellar magnetism. Each passage leaves its mark. The heliosphere expands and contracts, reshaping itself to the density of the medium around it. In its wake, it leaves magnetic ripples that could persist for eons, a faint record of our star's journey written into the interstellar fabric. It's a strange thought that somewhere behind us, millions of kilometers away, trails the magnetic memory of the solar system's past. If an alien civilization were to travel through that region of space, they might detect faint traces of charged particles, aligned in the same spiral pattern that defines our sun's magnetism. They would know, without ever seeing us, that a star once passed this way, that a living system of worlds once drifted here. In that sense, the heliotail is not just a physical structure, it's a signature, a cosmic autograph scrawled across the galaxy's magnetic canvas. It records not only the sun's movement, but the collective presence of every world bound to it. Earth, Mars, Jupiter, Uranus, all woven into the same luminous trail. One day, billions of years from now, the sun will fade, and the planets will be gone. But its magnetic footprint, those delicate spiraling threads, may still drift through the galaxy long after our light has vanished. A quiet testament to the journey of a star and to the worlds that once followed it. Below everything we see, space curves around the sun's mass like a vast bowl. Planets orbit along the edges of this invisible depression, bound not by force, but by geometry itself. To the human eye, space looks flat, a limitless expanse through which planets drift and stars shimmer. But the deeper truth is stranger, and far more beautiful. Space is not an empty stage where the universe plays out. It is the stage, the flexible fabric upon which all matter moves. And that fabric bends, ripples and curves under the weight of gravity. Einstein taught us that gravity is not a mysterious force reaching across space. It is space itself, distorted by mass. The sun, with its immense weight, doesn't pull on the planets the way a magnet pulls on metal. Instead, it bends the very geometry of reality, creating a depression, a gravity well, in which the planets move. They aren't being dragged around the sun. They are simply following the curved paths of space-time, like marbles rolling along the inner walls of a vast, invisible bowl. Each planet carves its own smaller well in this great structure. Jupiter's is deep and wide. Earth's is modest, enough to hold its moon close. Uranus's well, out at the edge, is shallower, its curvature gentle and slow. Yet all are nested within the sun's immense distortion, bound together by the shared geometry of light and mass. The orbits we see, ellipses traced across the darkness, are really the simplest possible paths through a universe that is perpetually curved. If you could see the sun's gravity made visible, the solar system would appear as a luminous whirlpool in the fabric of existence. Space itself would slope toward the sun, its surface shimmering and elastic. The light of distant stars would bend as it passed nearby, curving along the same invisible contours that guide the planets. This bending of light, gravitational lensing, is how we know that even distant galaxies and black holes warp the universe around them. Gravity doesn't just hold worlds together, it shapes the way we see everything. And the deeper you fall into that curvature, the more time itself begins to change. Closer to the sun, seconds stretch and slow compared to the outer planets. Time runs differently in every part of the gravity well, like the tempo of a song changing with depth. Light leaving the sun must climb uphill through space-time, losing energy as it goes, its wavelength stretched, its colour shifted ever so slightly toward red. The sun's light, quite literally, is tired by the time it reaches us. Every object in the universe sits within its own pocket of curvature, shaping and reshaping space-time like stones dropped into a pond. When galaxies gather, their combined wells form vast cosmic valleys, bending the paths of light for millions of light years. When stars collapse, they fall so deep into their own curvature that not even light can escape, a black hole, the deepest well of all. Yet here, in our small solar neighbourhood, the geometry is gentle, graceful. The planets move not as prisoners, but as dancers, gliding effortlessly along the slopes of the sun's gravity. They are not being pulled. They are falling, constantly falling around the sun in perfect perpetuity. When we look up and see the planets tracing their slow arcs across the sky, we are watching geometry made visible, the quiet choreography of space itself. The gravity well beneath us is not a prison, but a path, one that guides us endlessly forward, through motion, through time, through the elegant curvature of the universe. We live not above gravity, but within it, moving along the invisible contours of a bowl so vast, so perfectly balanced, that it holds the very shape of everything we know. The Milky Way's spiral arms are not static, they are waves of density rippling through the galaxy. Our solar system surfs one of these waves, riding its crest as it moves through space. At first glance, the Milky Way seems frozen in the sky, a vast, serene spiral of stars suspended in eternity. But appearances deceive. The galaxy is alive with motion. Stars orbit its center like leaves caught in a vast whirlpool. And yet, they do not all move in perfect unison. Some drift ahead, some lag behind. This imbalance gives rise to something extraordinary, a density wave, a pattern that sweeps through the galactic disk like the tide through sand, compressing gas and dust into luminous arms that glow with newborn stars. These spiral arms are not solid structures. They are more like the crest of an ocean wave moving through the water, while the water itself stays mostly in place. The stars you see today in the arm of the Milky Way will not be there millions of years from now. They will have moved on, replaced by others drawn into the same gravitational rhythm. The arm persists, but the stars within it change, forever flowing, forever renewed. Our solar system is one of countless drifters caught in this current. As the Sun orbits the galactic center, it passes through the spiral arms every 100 million years or so. Each time it does, the skies subtly change. The density of nearby stars increases, radiation grows stronger, and cosmic conditions shift. Some scientists even suggest that these passages may influence Earth's history, that when the solar system travels through thicker regions of the galactic disk, the rise in cosmic radiation could affect climate, mutation rates, or even the course of life itself. At this moment, we are gliding between the Perseus arm and the Sagittarius arm through a minor structure known as the Orion Spur. It's a quiet stretch of galactic ocean, a calm between the waves. Here, the density of matter is lower, allowing our solar system a kind of peaceful drift between the great tides of the Milky Way. But even in this calm, the undercurrent is constant. Gravity from the surrounding spiral arms subtly pulls on the Sun and its planets, keeping us tethered to the rhythm of the galaxy. If we could see the Milky Way from above, the spiral arms would shimmer like vast whirlpools of light, each one a ripple in space-time, sweeping through the galactic disk. Clouds of hydrogen collapse into stars at their leading edges, while older stars drift behind like foam trailing the crest of a wave. It's a breathtaking dance that has been unfolding for billions of years, and our tiny solar system is one small speck caught in its swirl. The scale is almost impossible to imagine. The Milky Way's spiral pattern rotates once every 250 million years, about the same time it takes the Sun to complete one orbit around the galactic center. This means that since the dawn of life on Earth, we've made only about 20 laps through the galaxy. Every orbit is a new passage through the cosmic tide, each one shaping our fate in ways we are only beginning to understand. The spiral arms are the heartbeat of the Milky Way, the waves that keep the galaxy alive, where stars are born, live, and die in an endless cycle of renewal. And as the Sun rides the crest of one of these waves, carrying its family of planets along, we become part of that rhythm too. We are travelers not just through space, but through the living motion of the galaxy itself, riding the cosmic undercurrent that has flowed since time began. The stars above us are not still. They are the shimmer of the wave beneath our feet, the silent tide carrying us home through the infinite sea of light. Even between stars, there is dust, carbon, ice, and silicate grains from long-dead suns. Each particle carries the story of stellar death and rebirth. To most eyes, interstellar space seems empty, a black, airless gulf between the bright islands of stars. But if you could drift through it and look closely enough, you'd see it shimmer. Not with light, but with presence. The void is not void at all. It is filled with fine grains of matter, tiny fragments of carbon, oxygen, silicon and iron, floating in near silence, scattered like the ashes of a billion dying stars. Each of these grains is smaller than a whisper, yet their collective effect is vast. Together, they dim the light of distant stars, scattering and absorbing it so that the Milky Way glows with a faint reddish haze. Astronomers call it interstellar dust, but that name hardly captures its importance. This dust is not debris, it is the raw material of creation itself. Most of it was forged in violence. When massive stars die, they explode as supernovae, ejecting their outer layers into space at incredible speeds. As that hot gas cools, atoms condense into dust, crystals of silicate, flakes of graphite, beads of frozen water. Lighter stars, like our Sun will one day become, shed their envelopes more gently, producing glowing nebulae that enrich the galaxy with carbon and oxygen. Over millions of years, the remnants of these deaths drift outward, colliding, combining, and spreading through the galactic disk like pollen on the wind. This dust, born from endings, becomes the seed of new beginnings. In the dense regions of the galaxy, cold clouds of hydrogen and dust, known as molecular nebulae, gravity gathers the material again. Grains clump together, forming the cores of new stars and the disks that will one day become planets. Every world, every ocean, every living thing is built from this cycle of destruction and renewal. The dust between worlds is the bridge between generations of stars, the cosmic soil from which everything grows. The scale is staggering. Between every pair of stars, even in the emptiest regions of space, there are still thousands of dust particles per cubic meter. They drift endlessly, bathed in starlight, coated in ice or carbon, occasionally struck by high-energy cosmic rays that change their chemistry. Some carry complex organic molecules, precursors to life itself, formed in the quiet darkness between suns. In this way, the galaxy may be continuously sowing the ingredients of biology across the stars, one particle at a time. When light from distant stars passes through these dusty regions, it's transformed. Blue wavelengths scatter, while reds and golds pass through, tinting the starlight we see from Earth. This is why nebulae glow in soft hues, why the pillars of creation shimmer with dusty opalescence, and why the Milky Way looks milky at all. The light of the cosmos is filtered through its own memory. Even here, in our solar system, this ancient dust still falls. Every day, tiny interstellar grains, older than the planets, drift through our skies, entering our atmosphere as invisible meteors. They settle in our oceans, our soils, our very lungs. We are literally breathing the dust of the stars that came before us. It's a humbling thought. Space between worlds is not an absence, but a bridge. Every particle floating between the stars carries a fragment of history, an atom from a sun that lived and died long before Earth was born. The dust between worlds is the galaxy's heartbeat, beating so slowly that only eternity can hear it. And as it drifts through the endless dark, it reminds us that even the emptiness between stars is full of stories, of endings, beginnings, and the quiet miracle of continuity. Dark matter forms the scaffolding of our galaxy. Without it, the solar system's orbit would unravel. It is the invisible framework upon which everything rests. If you could look at the Milky Way not in light, but in gravity, you would see an entirely different structure. The glowing spiral of stars and gas that fills our telescopes is only the skin, an outer shimmer wrapped around something far larger, far older, and far stranger. Beneath it lies a vast halo of unseen mass, stretching hundreds of thousands of light years in every direction. This is dark matter, the silent architecture that holds the galaxy together. It neither shines nor absorbs, neither reflects nor radiates, yet it outweighs all the stars, planets, and dust combined. It is everywhere, woven through the fabric of space like an invisible web. We cannot see it directly, but we feel its pull in everything that moves. The stars at the edges of the Milky Way orbit far too quickly to be bound by the visible mass of the galaxy alone. Something unseen must be holding them in place, preventing them from flying off into the void. That unseen mass, the hidden hand of gravity, is dark matter. It is the cosmic scaffolding upon which galaxies are built. In the early universe, moments after the Big Bang, matter began to clump together under gravity. But it was dark matter, not ordinary matter, that shaped the first seeds of structure. Invisible halos formed first, pulling gas and dust into their gravitational wells. From there, galaxies condensed like dew on a spider's web. Every star, every world, every orbit exists because of that unseen framework. Without it, the solar system's motion around the Milky Way would slowly unravel, drifting outward into the dark. Our own sun is caught in this vast gravitational architecture. As the solar system orbits the galactic center every 230 million years, it doesn't just move through a disk of stars, it passes through waves of dark matter. These invisible tides subtly tug on everything, distorting orbits in ways too faint for us to feel, but strong enough to shape the galaxy's evolution. Even the Milky Way's spiral arms trace the outlines of this hidden skeleton, their luminous patterns echoing the invisible geometry beneath. Scientists have mapped dark matter not by seeing it, but by watching how light bends around it. When the gravity of unseen mass distorts the path of starlight, it creates a phenomenon called gravitational lensing, a cosmic mirage that reveals where dark matter must be. Through these distortions, astronomers have pieced together a ghostly image of the universe's true structure: vast filaments of dark matter, connecting clusters of galaxies like veins of gravity stretching across the cosmos. And yet, for all our measurements, we still don't know what dark matter is. It could be exotic particles that rarely interact with normal atoms, WIMPs, axions, or sterile neutrinos. It might even be something more fundamental, a property of space itself that we have yet to comprehend. Experiments deep underground and far in space listen for the faintest whisper of its presence. But so far, the darkness remains silent. Still, its influence is everywhere. Every orbit, every galaxy, every cluster of stars owes its stability to this unseen architecture. The Milky Way is just one glowing spiral suspended in a cosmic web of dark matter filaments, connecting hundreds of billions of galaxies into one grand structure. The cosmic web, the largest known pattern in existence. It is humbling to realize that everything we see, every star, every planet, every life, is just the visible frosting on an invisible skeleton. The universe is built on darkness, and light is merely the decoration. Without dark matter, there would be no galaxies, no stars, no Earth, no you. We live on the surface of an unseen cathedral, its walls made not of stone, but of gravity. The architecture of darkness surrounds us always, silent, patient, and eternal, holding everything together while revealing nothing at all. Every 26 million years, the solar system aligns with the Milky Way's midplane, a passage that may trigger comet showers and subtle gravitational resonances across our system. Like a ship bobbing through an unseen tide, our solar system doesn't travel in a perfectly flat orbit around the Milky Way. It oscillates, rising above and dipping below the galactic plane in a slow, rhythmic motion that takes tens of millions of years to complete. Every 26 to 30 million years, the Sun and its planets pass directly through the midplane, the densest part of the galaxy's disk, rich with gas, dust, and gravitational currents. This crossing, subtle and silent, is part of a grand celestial rhythm older than life itself. To imagine the Milky Way's midplane, picture a glowing river of stars stretching across the cosmos. Most of the galaxy's mass, its stars, nebulae, and molecular clouds, lies within this thin band, only a few hundred light-years thick. The Sun's orbit wobbles above and below it like a pendulum, spending millions of years gliding through the galaxy's thinner outskirts before returning to the crowded heart of the disk. Each passage through this region is called a galactic plane crossing, a moment when the solar system is most deeply immersed in the gravitational tides of the Milky Way. Some scientists have suggested that these crossings might have consequences. As the solar system passes through the galactic midplane, it experiences slight changes in gravitational balance. The dense concentrations of stars and dark matter in the disk could tug on the distant reaches of our solar system, specifically the Oort Cloud, the vast spherical shell of icy debris surrounding everything. These tiny perturbations might dislodge comets, sending waves of them tumbling inward toward the Sun. If true, the periodic bombardments of comets on Earth, recorded faintly in the fossil record, may trace their origins to this rhythmic dance through the galaxy. Others propose that this passage influences more subtle forces. The solar system's magnetic field, intertwined with the Sun's heliosphere, interacts with the Milky Way's own magnetic structure. During each alignment, these fields might briefly merge, altering the flow of cosmic rays and solar winds that bathe the planets. The effects are nearly imperceptible. Shifts in atmospheric ionization, changes in cosmic radiation, but across eons, they could ripple through climates and perhaps even through the story of life itself. It is a strange and humbling thought that Earth's history, its mass extinctions and rebirths, might be connected not only to impacts and volcanoes, but to our position within the galaxy's invisible waves. The fossils in our rocks may carry the rhythm of our cosmic motion, like echoes of a heartbeat pulsing every 26 million years. The most remarkable part is that this motion never stops. Even now, the solar system is moving slowly downward through the galactic plane, like a bead sliding along an unseen string. In a few million years, we will cross the midplane again, completing another oscillation in our endless orbit around the galaxy's core. The great alignment is not an event we notice, not a moment that changes in an instant. It is a whisper across time, a passage through a field of gravity so vast we can only glimpse its consequences millions of years later. We often think of the solar system as an island, self-contained and serene, but in truth it is part of something much greater, a living galaxy that breathes, swells and shifts. Each alignment is a reminder that we are not separate from the Milky Way, but participants in its rhythm, passengers riding its spiral waves. Every 26 million years, we cross the heart of our galaxy's shadow. And in that crossing, the universe quietly reminds us, even the smallest world belongs to a cosmic dance that never ends. If you could stand beneath the solar system and look up, you'd see the galactic core blazing like an ember through layers of dust. Below us lies not emptiness, but the glowing heart of the Milky Way. It's easy to think of up and down as directions that belong to us alone, concepts that lose meaning in the void. But in the grand geometry of our galaxy, even the solar system has an orientation. We orbit the Milky Way tilted at an angle of about 60 degrees relative to the galactic plane, rising and falling as we circle the center. If we could stand on a cosmic platform below our orbit and look upward, the sight would be breathtaking. Below us, stretching across the dark, would glow the galactic disk, a river of light made from hundreds of billions of stars, their collective shimmer softened by clouds of interstellar dust. At its center, like a burning coal half buried in smoke, the galactic core would shine. Its light, reddened and diffused by distance and dust, would pulse faintly, marking the location of something extraordinary. Sagittarius A star, the supermassive black hole that anchors the Milky Way itself. From this vantage, the solar system would appear to drift through a thin, translucent haze of starlight and gas. You'd see the plane of the galaxy curving away in both directions, a glowing band hundreds of thousands of light years long, wrapping around us like a halo. The stars near the core would appear tightly packed, merging into a radiant blur. Farther out, the light would fade, breaking into delicate threads of silver where the spiral arms sweep outward through space. The core's glow is ancient light, photons that have traveled tens of thousands of years to reach us, filtered through curtains of carbon dust. If we could see in infrared, those veils would lift, and the full majesty of the galactic center would reveal itself. Clusters of newborn stars orbiting in tight, brilliant swarms, supernova remnants glowing like embers, arcs of plasma curving around an invisible singularity with the mass of 4 million suns. This is the heart of the Milky Way, where gravity and creation intertwine. And yet, from Earth, that heart is hidden. The thick dust between us and the core obscures most of its light, leaving us only a faint, hazy stripe, the Milky Way we see on summer nights. But spacecraft and infrared telescopes, like Spitzer and JWST, pierce that darkness. They show us the furnace that burns below, the sky we never see, the galaxy's radiant foundation. In this perspective, below is not emptiness, it is abundance. It is the galaxy's deep interior, the gravitational basin into which everything falls. The stars we see overhead are only the froth at the surface of something immense, a disk of light and matter that stretches for 100,000 light years beneath our feet. If you were to turn around and look above, you would see the opposite. The halo, thin and diffuse, filled with ghostly stars and streams of ancient globular clusters, remnants of the Milky Way's formation. It is quieter, colder, emptier. Below, the core blazes with creation. Above, the halo whispers of age and decay. Between them drifts our fragile solar system, suspended like a dust mote between fire and silence. We often speak of looking up at the stars as if the cosmos were above us. But from the galaxy's perspective, we are simply inside it, immersed in its light, its dust, its motion. Up and down lose meaning here, only connection remains. So if you could stand beneath the solar system and gaze upward, through the dust and darkness, you would see not a void, but the glowing sky below us. A sea of stars, a furnace of birth and death, and the quiet reminder that even in the coldest corners of space, something still burns with unending light. Every atom on Earth once drifted in space before being forged in stars. Above and below the solar system lies the same cosmic material, recycled endlessly through the universe's eternal heartbeat. If you could follow a single atom of carbon in your body back through time, it would tell a story older than the Earth itself. Long before you breathed it, before it settled into the oceans or the trees or your blood, that atom was part of something else, a star, burning bright in the young galaxy. When that star died, it released its contents into the void, scattering the raw ingredients of life into the cosmic wind. Those fragments, carbon, oxygen, nitrogen, iron, drifted for millions of years, carried through nebulae and gravitational tides, until eventually they came together again to form a new world. Our world. This is the breath of creation, the endless cycle through which the universe renews itself. Stars are born, they live, they die, and from their ashes, new stars and planets emerge. The material of existence is never destroyed, only reshaped, passed forward like an inheritance. Every rock, every drop of water, every living cell is part of this continuity. You are, in a literal sense, made of the universe's memory. The hydrogen in your body is nearly as old as the cosmos itself, formed in the first 3 minutes after the Big Bang. The calcium in your bones was forged in the heart of a massive star that exploded billions of years later. The gold in your veins may have been born in the violent merger of 2 neutron stars, an event so rare that it reshaped space-time itself. The oxygen you breathe, the iron in your blood, the silicon beneath your feet, all were once the glowing embers of something vast and alive. And when those stars died, they exhaled. Their final act was to release everything they had created into the dark, enriching the galaxy with the materials that would one day make planets, oceans, and eventually consciousness. The same process continues today. All across the Milky Way, new stars are forming in clouds of dust and gas, clouds seeded with the remnants of generations long gone. The universe, in its quiet rhythm, is still breathing. Above and below the solar system, in the cold interstellar medium, that breath flows like an invisible current. Hydrogen atoms drift together, drawn by gravity, cooling until they collapse into new stars. Supernovae scatter their heavy elements outward again, feeding the cycle. From chaos comes structure, from death comes creation. Every element heavier than helium, the elements that make life possible, exists because the universe learned how to recycle itself. On Earth, that cosmic story continues in miniature. The same carbon that once formed the bones of ancient creatures now flows through forests and oceans, through your lungs and the air you exhale. With each breath, you are part of that cycle, returning atoms to the world that will one day become part of something new. Life, death, decay, and rebirth are not separate phenomena. They are the same universal process, written in matter and motion. So, when we gaze at the stars, we are not looking at something foreign or unreachable. We are looking at the source from which we came, and the destination to which we will return. The boundary between us and the cosmos is an illusion born of perspective. There is no separation, only transformation. Every heartbeat, every breath, is a small echo of the universe's own rhythm. The same pattern that drives the birth of stars drives the beating of your heart. The same atoms that once illuminated the galaxy now shimmer quietly within you. We are not apart from the universe, we are its continuation. The breath of creation flows through everything, forever expanding, collapsing, and beginning again. And in that endless rhythm, you and I, the Earth, and the stars are all just different verses of the same eternal song. Perhaps, somewhere above or below our system, a signal drifts through interstellar darkness, an ancient message, or a whisper from another civilization watching from afar. And maybe, one day, we'll answer. The thought is both thrilling and humbling, that beyond the quiet hum of our own transmissions, another voice might already be speaking, its message crossing the vast gulf between stars, faint and patient, like a bottle cast upon an infinite sea. For more than a century, humanity has been listening. Our great radio telescopes, from Arecibo to the Allen Array, have swept the heavens for signals that break the randomness of the cosmic static. And though we have found no clear reply, the silence itself has a kind of beauty, an expectation suspended in eternity. Above and below the plane of our solar system, space expands into the interstellar medium. A cold, thin ocean where signals once launched can travel for eons. Every pulse of radio energy, every encoded message stretches outward endlessly, passing nebulae, dust, and the faint gravitational distortions of unseen planets. Somewhere, our oldest broadcasts, our first words, first songs, first mistakes, are still moving outward, forming a faint sphere of human presence nearly 100 light-years wide. It's strange to imagine that, while we sleep, our voice continues to travel. Out there, the signature of Earth grows dimmer with distance, but it never truly vanishes. A whisper of civilization drifts through the galaxy, faint but persistent, the electromagnetic heartbeat of an intelligent species daring to be known. And what of those who might be listening? Perhaps, in another system orbiting another star, a civilization far older than ours built their own telescopes, their own dreams of contact. They may have launched signals ages ago, beams of concentrated thought encoded in radio or light, traveling outward in every direction. If they aimed one toward us, it might already be passing silently through our skies, so faint, so subtle, that our instruments cannot yet detect it. Or perhaps it has already come and gone, its message lost in the noise of cosmic background radiation. The odds seem impossible, but the universe is vast beyond reason. There are, by some estimates, more planets in our galaxy than grains of sand on Earth's beaches. Even if only a fraction of them host life, and an even smaller fraction intelligence, the possibilities remain staggering. Somewhere, in the darkness between the stars, someone else may be wondering the same thing. If such a signal exists, it might not come in words, but in rhythm, pulses of light or radio that reveal intelligence through pattern and intent. It could be a greeting, a warning, or simply a declaration. We were here. Like our own Voyager probes, it might carry a map, a melody, an image, fragments of beings who refuse to remain silent. But maybe the signal isn't meant to be found now. Maybe it's timeless, waiting for the right civilization to evolve, to learn, to listen. It could be passing through us every day, woven into the background hum of the universe, unnoticed only because we haven't yet learned to recognize it. And one day, perhaps far in the future, we will. We'll detect a pulse that isn't random, a rhythm that repeats with purpose, and in that moment, we'll realize that the silence was never empty. It was full of waiting. The signal that waits is not just theirs, it's ours too. Every message we send into the dark is an act of faith that someone, somewhere, will someday hear us. And even if no one ever does, we have still spoken. We have filled the void with meaning, and in doing so, proven that we were not afraid to reach beyond ourselves. Because in the end, that's what defines us, not the answers we receive, but the courage to keep sending our voice into the unknown, hoping that somewhere in the great ocean of stars, another voice is waiting to whisper back, and now, we return home. After drifting through the layers above and below our solar system, we see the familiar sun again, our golden anchor suspended in the dark. Around it, The planets trace their endless patterns, unaware of the vast structures that cradle them from beyond sight. Above us still hums that invisible ocean, waves of energy, ancient light, and cosmic whispers that have travelled across time to reach this tiny corner of existence. Below, the galaxy's hidden skeleton, dark matter, magnetic rivers, and forgotten tides continues its silent work, shaping everything we see without ever being seen. We began this journey to glimpse what lies beyond the ordinary, to peel back the comforting illusion of emptiness that surrounds our world. And what we found is that there is no emptiness at all. Every space, every silence, every shadow between the stars is alive with connection. Invisible forces hold us, unseen light bathes us, and ancient dust binds our history to the birth of the universe itself. Everything above us flows into everything below. The solar system is not an island in space. It's a bridge suspended between two infinities, the radiant sea of cosmic energy above and the deep gravitational roots below. Together, they form the architecture of existence, the unseen design that allows our fragile world to be. So, as you drift towards sleep tonight, imagine yourself floating in that balance between light and dark, between motion and stillness. Feel the quiet pulse of the galaxy beneath you and the soft radiation of starlight above. You are part of that equilibrium, woven from the same elements, breathing the same ancient breath that moves through the stars. Above and below, the universe is never still. It dreams, it hums, it holds us. Thank you for joining this journey beyond the solar system's surface. If this voyage stirred your curiosity, if it made you see our small world with new eyes, consider liking this video and subscribing for more cosmic explorations. Until next time, rest well, traveller of stars. You are home in the universe now.